come to the first row. Vengan todos a la primera fila. We have the instructions to start at 10 a.m. sharp.
And we're very mean, as you know, so actually here's the first presenter, and he's only got 10 minutes left, but
10 a.m.
he's
sharp.
very talented. So,
9 minutes now.
and if you haven't loaded your presentation,
So let me first of all make this session the most instructive and networking as possible. We are here with a common goal of to foster clinical engineering in all our countries, and let us hope this sharing of information and of different realities in different countries can help us both network, so know each other. I think this is a good opportunity to interchange all our emails and all our names in this session. So one possible way would be to ask our helpers here to have a list where every one of us during the following hour or so will write on a piece of paper name, surname, email, and country maybe, so that we can identify each other in this session. The advantage of having such a reduced number of people in a session is this: we can have this as the first session, the first moment for future collaboration, exchanging students, visiting each other, using the standards for safety of medical equipment, criteria, even spare parts. I don't know, spare parts of human beings we don't sell yet, but spare parts of equipment maybe. So the session today spans a large number of different realities from several continents. In all cases, we all tend to the best quality of healthcare by the use of the appropriate use of good equipment, good maintenance, CMMS, and all the things you know about that we can share today. I think we will all, I'm sorry, I think the camera didn't record me. I was not looking at the camera. Do we have anyone online? No? It would be interesting to include them. Do any of you know of colleagues in their home countries that would connect to this? No? Yes? From Peru? No? So we have people from Peru, we have people from Italy, actually even the Paraíso, quelli del Paradiso, no? How do you call the people on it? From Peru, from Italy, from Brazil, bem-vinda. Você também é brasileiro? So? Ghana, sorry. We have people from Argentina, you can tell, it's easy for us, sorry. We have people from India, Australia, not far from here, isn't it? Not far. Any other country I didn't mention? You're probably from India as well? Yes. Mauritius, nice to meet you. I didn't know about, and the US. So we have about a real nice representation, I should say, of all continents. The 5 continents are here. We have Australia, we have Africa, we have Americas, both North and South, actually a larger representation of South America. We also have the US here, of course, always around, and they're part of the organization of this meeting, and of course we have Europe. Can we confirm that we have no one from online? So it's all us. I don't have to talk like this to the camera. this would have been sort of strange to talk through to the camera and having you behind, but so we can talk like this. Buenas tardes, adelante. This gentleman also comes from Argentina. We can say hello to him, one of the great pillars of clinical engineering. But please come to the first line. Tenemos una noción de orden de que los democráticos se sientan en primera fila. Yes. So, any suggestion from the floor about this meeting? You would like to say something before we start the presentations? May I start? Posso incominciare? Yes. Manto. This very brief presentation is the result of a diagnostic we have done in Uruguay about the lack of professional clinical engineers in our hospitals. The industry has understood a long time ago, more than a century ago, that engineers are necessary within industry. Hospitals have not. And in Uruguay, most hospitals have no engineers whatsoever working in the hospital. At the most, outside asesores, outside people counseling the hospital, sometimes some electricians in-house, but very, very seldom Uruguayan hospitals, both private and public, have engineers. This is a diagnostic, and the situation is that the hospitals rely upon purveyors, external companies, to sell equipment and to do the service and to take care of the equipment. But of course they are outsiders and the interests are not the same. So how could we revert, how could we change the situation in the country and promote the study, promote the graduation of engineers who are able to take care of a hospital from the point of view of the equipment, first of all, and the installations. So we called it MANTO. MANTO is a contraction of mantenimiento. And so mantenimiento for short, we call it MANTO as the code name. Next slide, please. Or can I have this? Thank you. Which is next. So first of all, let me introduce myself for the people who do not know me yet. My name is Franco Simini, and I come from a little place called Núcleo de Ingeniería Biomédica, which means something in English like the nucleus of a cell. The central part of a cell is called núcleo, and instead of calling it a department, we called it Núcleo de Ingeniería Biomédica. We are both part of the School of Engineering and the School of Medicine, and we are located inside the university hospital, where the problem in biomedical engineering arise, and where we can detect if there is any new idea, any new thing to be developed as a prototype within the university, and start a research line on that. We both do graduate, postgraduate lessons for students in electrical engineering, students in mechanical engineering, students of medical school, and students of medical technologies. All those careers have some electives, optional courses, which we give. So to address this problem I was telling you about, to have people graduate, people studying clinical engineers, we devised a system which involves both hospitals, universities, students, and instructors. We have these 5 letters. We will go through them successfully. First of all, we have a list of hospitals who agree to take part in this system, who do not have local engineers working for them. We also have undergraduate students, mostly electrical engineering students or mechanical engineering students, who are like biomedical engineering. We don't have as such a career in biomedical engineering in Uruguay yet. We have other careers in engineering. A second interesting thing, letter C, is engineers who also like clinical engineers, have a degree in engineering. It's mostly what in Europe you would call a master's degree, because it's 5 years of nominal duration of the career, but mostly students graduate after 7 or 8 years after secondary school. And we call them engineers, ingeniero, but they are what in Europe you would call a master's degree. And these people also like to have a further education, and we offer them a practical education working as engineers in a hospital with academic supervision from us to make some studies, take some specialized courses in clinical engineering management and such. And of course we need biomedical engineering or electrical engineering staff to supervise both the interns, who are undergraduate students, and the residents who are engineers. This is taken from the medical school kind of education. Medical schools have interns during the undergraduate years of medical school, and they also have residents. A resident in gynecology, a resident in neurology, a resident is usually a medical doctor working during 3 years, 5 years to get a specialization degree. So we're suggesting to have for clinical engineering also a specialization degree earned by working, not earned just by studying or giving exams. You earn a clinical engineering degree by working as a clinical engineer. And at the last item is our group supervising this sort of thing. So, the hospitals, what do the hospitals do? They must hire interns to work for them during 6 months period, after which the intern changes. And there is a turnaround of biomedical engineering students who every 6 months change in a hospital. And they do the basic things a hospital needs in clinical engineering. And the hospital also has to offer positions for residents and also have a basic structure for clinical engineering within the hospital, which is something the hospitals in Uruguay at least do not have. Hospitals in Uruguay do not have clinical engineering departments. They have no room dedicated for clinical engineers. The companies come in and go and take the equipment and go back and forth to their companies, but there's no place in-house to do a first diagnostic, to install a system, to study the system, and so on. So this is what the functions of the hospitals do. Second item is the undergraduate student, the intern. During 6 months, he or she will be hired by a hospital, will be supervised by a teacher somewhere in the university, and will perform the basic functions of CMMS operations, computerized management system, maintenance management system, and he or she will receive basic health training, and at the same time will talk to nurses and talk to medical doctors from the technology point of view, and this will train him or her as in the people who can talk to medical doctors, which is not easy for an engineer. And there is an evaluation every 3 months of this intern, And there is also, when the next intern comes, there is a parallel period of time so that the new intern can get instruction from the previous one. And here comes the real thing about this system, which is the resident. In Argentina, there are several places where you can study una residencia en ingeniería clínica, but not yet in Uruguay. And so we're suggesting to have 3 years of an engineer working in a hospital, mostly part-time, 20 hours a week. It was what we found suitable for the labor market in Uruguay. And this person will have the responsibility to manage clinical engineering within the hospital. And this person will be 3 years working in a hospital as R1, resident first year, R2, resident second year, and R3. So every year there's a new resident coming in. And this is an ongoing situation where you always have 3 engineers working per hospital. For a medium to small size hospital, 3 engineers may look a lot, but it is necessary nowadays to have things to put on the right foot, especially because there are a lot of functions now being done to the day that have to be put in place. And also we have this factor about training, in the sense that these 3 engineers are not as productive as 3 knowledgeable engineers. They are engineers being trained as clinical engineers. So this is why we must have 3. One with more experience, one with half experience, and one just new engineers. These 3 are in addition to the interns. Remember, we have interns who are undergraduates, and these are graduate engineers. And they are performing all the high-level management tasks in the hospital. And then we also have a local university attached to every hospital where instructors, professors, are in charge of the supervision of all these both residents and interns. We don't have enough qualified high-level teachers to be at the same time working in a hospital and being supervisors of students as the medical doctors do. Medical doctors typically are very highly qualified medical doctors in the hospitals, and they train residents by their sides. They have residents in the operating room with the high-level medical doctors. We don't have that for engineers. So the reference people for the formation and the training must be in a local university, maybe 10 blocks away, or in the nearby town. And this reference engineer is somebody the residents and the interns call upon once in a while when it is needed. And this is not as important because it is our own group, in the sense that we will be supervising both the teachers, the professors in the universities, and then second level, the residents, and third or fourth level, the interns in the hospitals. And the duty of this coordinating group is to have all this experience being recorded and published and evaluated at the same time, doing all the same. And this is a simple mathematics as a suggestion for the number of residents and number of interns we will need for different types of hospitals, because this is a primary suggestion that will make the situation change from night to day, or change completely in the sense of really taking a professionalization step in hospitals in Uruguay. So these are the hospitals where we have been trying this scheme right now. Not only one hospital, but all these hospitals. Hospital Maciel is a public hospital in the center of Montevideo. Hospital Tacuarembó is 400 kilometers from Montevideo. CAMEC is a private hospital 100 kilometers from Montevideo. British Hospital is a private hospital within the city. And last and not least, Instituto Nacional de Donación y Trasplante, Organ Donation Institute in Montevideo, which has plenty of equipment to be taken care of. And this way we're also suggesting as a model, we are signing a memorandum of understanding with Bolivia, where we will put in practice this system with 4 universities, 4 university hospitals, and lots of both professors, students, and engineers working following this model. And the lessons learned so far is that we need overlapping of interns when they success each other in the hospital. We need an overlapping time so that the old student can teach the new student things. We need to have clinical engineering courses in parallel with the practical training. It's mandatory to have that. And it is very difficult to recruit the appropriate students. You need a lot of time for that. And at the same time, recruit universities. And we always need additional money to travel to do all the supervision of this. And I think that is it. Thank you very much. So before giving the floor to the next presentation, a quick question on this, please.
Wonderful presentation, thank you. I do have a question. How do you determine the amount of time you need to become a clinical engineer? Why 2 years or not 2, or why not having like a master degree or something?
Well, the question about the master's degree is interesting because a master's degree would be an academic position, and we still have that. We have students who follow the academic way. In Uruguay, you get a master's degree sometimes in 3 or 4 years. So you get a master's degree about 30 years of age or more. And those people are usually preparing themselves to be professional professors or teachers or instructors within the university. We have seen that the students are mostly interested in getting a job as soon as possible. And this job, if we don't give a protection, an academic protection on a job, we call that a residency. And why 3 years? Well, because most medical specializations are 3 years beyond the basic university degree. And it is a guess, if you like, but it looks reasonable to have 3 years of practical work as a clinical engineer to get a degree of this. And second, we looked at our neighbors in Argentina, and they usually have 3 years of residencies for clinical engineering. This is why we took that, taking advantage of previous experience on that. Any other question?
Thank you very much. That's very interesting topic. My question is, during the residency period, do the students get some allowance? Because like nurses and doctors who also do residency programs, they are enrolled by the hospital and then they are on government payroll. So do they get allowance during the residency period? And then the second question is there any way that you can collaborate with some universities in Africa to replicate the same model? Thank you.
Yes, I'm afraid I was not clear enough in the sense that both the intern receives a salary. The intern is working 8 hours a day as a student in a hospital during 6 months, and he or she receives a salary as an intern. And of course, the resident, who is an engineer altogether, during those 3 years, he's an employee of the hospital, but he has academic supervision from us. So it's a three-way memorandum of understanding. Every time we have a resident in a hospital, we sign a memorandum of understanding by which the hospital hires the person, and at the same time we supervise the engineer or the student. This is for the first part of the question. And the second part of the question, yes, definitely. We're absolutely very happy to work with any other country that would help us to cooperate, because this is a two-way cooperation in the sense that we may have some experience in teaching clinical engineering, but we also learn out of every experience we can undertake. So let us interchange names, as I said at the beginning, and we can work with Ghana with pleasure. Any other question?
Thank you very much for this explicit, structured framework, or what we can call it like a knowledge transfer partnership amongst academia, hospitals, and medical companies. I'm just wondering if we just take a look at the CMMS. Nowadays, most of the hospitals are facing situations like need to decrease the turnaround time for equipment which fail down eventually. The aim is to restore it in normal time. Which type of approach in terms of maintenance has been considered in the CMMS? We know that we have proactive, preventive, predictive maintenance. But will it be nice to have like reliability-centered maintenance as approach for medical equipment? Because this is used normally for the maintenance of in-flight, because if you consider the risk of patient, it's a life-saving approach that we have to take in order to, let's say, bring a smile to the face of patient eventually. Thank you.
That's a very, very good question, actually. This is the first level to tackle the problem. You are addressing maybe the second or the third level. We first have to have a highway and then buy the car or the truck, in the sense that now trying to have making the efficiency better on the turnaround time is maybe a second level of concern. We first of all have to have the highway for the things to happen. We have to have engineers within the hospitals, whom we do not have today. And of course, there's CMMS that comes after, the algorithm to make things better. And even I have my doubt about centralization, but then to discuss if it's better to have a centralized CMMS for several hospitals, which usually does not work, and versus having a local logistics and a local management within the hospital, which looks a lot bit more efficient. But anyway, I'd like to question, because you're already addressing the second and third level of efficiency. Thank you. Can we move on to the next presentation? Yes? So thank you very much again. And we're now calling upon, thank you. I suppose Mohammed El Fadi, can you please start your presentation? Not in the room?
Sometimes we're able to get it to our IT friends, sometimes we're not. So in other words, this won't be 15 minutes, this will be short, but we will give credit where credit is due. And I think it's true also of the following speaker, Franco. Yeah, in fact, am I okay with the camera sitting here? Okay. So this is from Sudan. Think about the setting, and it's the title is "The Effects of War on Healthcare Technology in Sudan." And he and a colleague from the Sudan Biomedical Engineering Association, which is their National Clinical Engineering Society, and he goes on to talk about the human impact. You know, and we know that Sudan and South Sudan are politically divided, but there's war going on there. You don't want me to describe that. I cannot. But it stopped, you know, many health facilities out of service. I mean, maybe think of Gaza at this moment. Stopping of health facilities in the capital of Sudan, Khartoum. 60% of the medical devices are provided in the country, so they're, you know, healthcare is concentrated in the capital, but the capital is being shut down. So they did a quick study of that. So the goal of the project was to outline the impact of war on the population and the facilities, as well as the use of health technologies, and to help prepare others for HTM during war. Let's see if I can see this better. So what were the results of that? There was a lot of power outages, you know, and of course that affected clinical labs particularly that need a lot of cooling. It affected CT and MRI because of uncontrolled temperatures. The unavailability of medical engineers as a result of, you know, people's lives being disrupted in so many different ways, emergency evacuation of hospital workers, you know, so you can, and then all the control systems in hospitals and utilities and beyond being affected, and, you know, sterilization and on and on. He gave the specific example of dialysis machines because they had to stop because they couldn't do things. And so, anyway, he delved into what do you do with HTM during war? And it's a very good presentation, and it'll be published for you. This is, maybe he sent us an updated presentation. Is that what's on the screen now? Okay, well, people can see that. Maybe go on to the next slide. So a National Medical Device Registry certainly helps to know what you have and be able to say something about it. Maybe next. Maybe that was it. Go on and set up Naranjan Kampete, who is the third. Yeah. So this is what people, okay, it starts to show some of the pictures and the challenges that I talked about. Extending capacity during war. In other words, maybe donors helped with the $130 million to help get healthcare facilities back into operation. Okay? All right. Let's move on to the next presentation. I don't know if you have anything from our colleague, Mr. Kampete. So let me go back to the drawing board here very quickly. And our friend from India, Pune, also in the last day or so, you know, this is Diwali weekend, of course, here in the country, and there were some health challenges in his family, so he's not able to be here. So Dr. Naranjan Kampete, K-H-A-M-P, you can see it in the Program Manager of Clinical Engineering there in Pune. I think that's a large teaching and research hospital. And he goes on to say, you know, the uniqueness of clinical engineering to make a difference in these kinds of situations. He demonstrates examples how the role of clinical engineers continues to evolve. On one hand, to address broader issues of quality management and patient safety, otherwise getting more focused on technology-intensive, specialized clinical care at the bedside. I mean, these are themes that all of us think about all the time. His results are small, but I'll make them bigger. One thing that's happened in his part of the country is there's an increasing number of hospitals in India seeking accreditation from national and international bodies. All right, who would know what's the accreditation for hospitals international? JCI? Joint Commission International is the right. Gold Star. You're welcome. So I'm a young guy, but I have these glasses. What else? He goes on to, so if the hospitals are there's a rising tide of capability in hospitals and a rising need and demand in hospitals around quality, that affects clinical engineers. I don't think we have to struggle to figure that out. He goes on to say another bullet, enhancing patient safety is an essential aspect of accreditation. Yes. So CEs are driven to projects involving electrical safety and other kinds of safety, for sure. And then he goes on to say, at the other end of the spectrum, due to their deep knowledge of biomedical engineering and good understanding of management, CEs are increasingly being considered eligible to become members of clinical care delivery teams. I mean, maybe that's already happening in many of your countries, but this is a growing phenomena in Indian healthcare in his part of the country. One way to get a sense of the scope of 1.6 billion people that are in this country is, and I was in the next room, and it's not about me, this is about Jitender, is the comment I want to make. And AMTZ, I mean, you heard yesterday of the incredible numbers of millions of IVDs made daily on this property during COVID. Thousands of ventilators, thousands of oxygen concentrators made daily and pushed out to the country. So how did they get out to the country? Well, there was 80 warehouses. So that says something to me about the geography. You know, that one warehouse, which is also a service center, and I mean biomedical equipment service center. So it's like 80 regional offices that had, you know, could move stuff in, move stuff out. And we were talking about next door, impact measurement discussion that they could send thousands of oxygen concentrators that they made here daily. And we know oxygen concentrators are used in hospital care, but they're also used in home care, in the right hands, you know, helping people top up their oxygen saturations during COVID. And so you could rent an oxygen concentrator from one of those warehouses through Uber. So, and we think, you know, we think about in my country, Uber, yeah, that'll take me from here to there 15 minutes. Well, I think you guys know a little bit about transportation challenges from the last couple of days. Okay. But anyway, to have this delivered to your house for $5 a day, once again, in my economy, doesn't sound a lot. This means probably only the middle class, right, could afford that in India. Somebody do a quick calculation how many rupees that is. But anyway, you get my point. But that is making oxygen concentrators available to the public in a cool way. So back to what you were talking about there, Tom, on behalf of my friend Naranjan. All right. All right, so crucial to the evolution of the role of clinical engineers is the need for periodic upgrade of their knowledge in multiple cross-disciplinary fields and acceptance among the medical fraternity to this changing role. And that's the end of his presentation. But, you know, I think we heard, you know, very dynamic presentations from Ricardo Silva yesterday about how our role is changing. And digital care, I don't know, I'll make a small joke. You know, our friends from Canada, the Prime Minister of Canada and the Prime Minister of India don't get along. I don't know if you knew that. So they stopped all of our Canadian colleagues from coming to this. Oops. But why am I bringing up Canada? Well, hockey's kind of big deal. And so in sports analogy, where is the puck going? So if you want to score, you got to not send it to where the guy or gal, women play hockey, where they are, you got to send the puck to where they're going so they can score a goal. Where his healthcare is going, if you want to send knowledge towards where healthcare is going, you send knowledge towards digital health. That's where the puck is going. That's where healthcare delivery is going. And so how can we do that? That's what Ricardo was talking about yesterday. I'm a certified clinical engineer. I think Mary's a certified clinical engineer. Others in the room. That's good, but that's kind of old news. What we need is certification and understanding how to apply digital health tools. And that's what CEIT, Clinical Engineering Information Technology, is one way we talk about that. But Ricardo was specifically talking about how can we load that knowledge into a training and education and certification program around CEIT. So let's go on to the next. I don't know if they're in the room either. And what's the topic? Is this, okay. And, yeah, and so we can, Franco, here it is, okay. You're welcome to drive it, I'm welcome to drive it.
I need, thank you very much.
And
So that we can show this presentation.
Allie, do we remember what country this is from? Mexico. So who's in Mexico in the room? To give us context. Okay. Can you help us make it work? All right. I think this is this the group of many young Mexican biomedical engineers? I think it is. Because this is a very large team, but anyway. Maybe next.
I don't have it as a Mexican team. Yes.
But anyway, let's maybe go to the third slide if we can. So we see where they are in Mexico.
San Luis Potosí, very fine city. And it's called San Luis because of a French king, and Potosí because of a Peruvian metal mine out of circumstantial information. And this is how they closer. Okay, thank you. This is the number of equipment they have in this system.
And I'll just add, we've all seen an evolution of sizes of clinical engineering departments in hospitals over the last 10 years, and these guys were no exception, and we see the kind of surgical loading they have with a lot of technology involved.
And this looks very much like my own presentation about 10 minutes ago, in the sense that they, same as Uruguay, they had no specialized clinical engineers within the hospitals, and they're stating here that they had 2 administrative background people to service 1,500 medical equipment or so, which is a strange situation. And they suggest this number of people to take care of the clinical engineering department with leadership, liaison, and practical staff working with 4 people called staff in training, which is very similar to the intern we were talking earlier today. To answer one of the questions we had earlier, having 4 or 5 people in a hospital taking care of the equipment is absolutely not too much. It's absolutely necessary.
And Franco, I would just say in terms of specialty, like you were saying, HT maintenance service, so traditional PM and repair, traditional medical devices, so that's kind of the base, but then user training is what we saw next. Then PACS systems, all the imaging, administration of medical images, and then working with physicians during minimally invasive surgeries. We know there's been a rise clinically in healthcare in the last 10, 20 years about minimally invasive surgeries.
Absolutely, definitely. And that mention of the CEIT people is very, very important nowadays. CE is not alone in the world. CE must ally and be part of the IT also, not only because of PACS equipment, but every medical equipment is linked to the clinical electronic record today. So all clinical engineering is also IT engineering at the same time. So this is statistics on the procedure they're having in that hospital, saying the growing number from 2022 to 2023, it's sort of increasing a lot. And the maintenance services, this is statistics to be a justification of what they're suggesting. And the training program has 4 biomedical engineering students interested in developing a career in the clinical engineering field to be part of the staff of the hospital of a duration between 6 and 12 months. And you can so compare this to our suggestion of having 6-month training periods for undergraduate students. And this is the result of 29 biomedical engineers being formed and instructed in the last 10 years, about three a year. And response to the COVID-19 pandemics with specialized changing of installation for making better the asepsis of the air. And in conclusion, actually they're suggesting the day of the biomedical engineering. In Spanish there's either ending with an A or an O, depending on the gender of the person, ingeniero biomédico or ingeniero biomédica. And the new thing here is that the basic name is shifted from the masculine to the feminine. This is why they say Día de la Ingeniera o Ingeniero Biomédica, and then in second place biomédico, which is a change.
So a short way of saying is women rule.
That's right. We're having a lot more women interested in biomedical engineering in Uruguay compared to men. It's about 2 to 1 proportion. We have more women engineers than men engineers in the biomedical field, not in the rest of engineering, which is almost all male, but in biomedical and clinical engineers we have roughly 2 females for 1 male throughout the years.
I was thinking Mary from Peru could do an intervention if needed.
Yes, definitely. So I think this and it maybe can round up this presentation from the people on San Luis Potosí. Does anyone wish to see again one of the slides or make some comment? We can pass over to the authors. And in case there are no other questions or suggestions on this, I have met personally the people in San Luis Potosí last year. They are doing a very, very good job with a career in biomedical engineering in San Luis Potosí. So it's a special place to do biomedical engineering. So let us move on to the next presentation. If you're people from Spain, anyone in the room? Yes? Eugenia Mercado, please. Yes, the floor is yours.
Hello. Well, hello. We're going to present our job based on the environmental impact of healthcare facilities. This is our team group. Claudio Mirovic, biomedical engineer and hospital planning specialist, CEO, founder of Mirabet Consulting, and I am Eugenia Mercado. I'm a biomedical engineer and I work for Mirabet Consulting as well. It is a consulting company based in Spain, that collaborates in hospital planning and clinical engineering and hospital architecture all around the world, especially in developing countries. So the healthcare sector is as much as an industry as any other industry, and generates contamination, and its impact increases to 4.4% of the overall emissions of global net emissions. So it's important to highlight that these numbers are prior the pandemic of COVID in 2019. So it is expected that this number has increased, and we don't have a certain number of how much impact we have right now. So why did we decide to explore this area? In the last years, after the pandemic has ended, sustainability has been put back into the table to discussion to gain, to be able to obtain funds for countries, or to develop any assessments or for procurement processes. So WHO, UNOPS, and funding institutions are including sustainability as one of the key factors for procurement processes. So some of the objectives that we have here is to explore how to perform an evaluation of sustainability in a hospital based in medical equipment. So there is it's a vast evaluation. We should evaluate the facilities, we should evaluate the construction, we should also evaluate how are what is the behavior of the hospital, and finally we should evaluate what is the role of medical devices in a hospital. So during this presentation we will evaluate, we will see current models that exist, we will explore new models, we will determine it and show an example of how to evaluate a medical device, and we will propose new or future lines for work. So in this graphic we can see a current and existing model performed by the University of Zurich. It was this model was performed in 33 hospitals where they evaluated the main impact categories for sustainability process. So what we can see in this model, and in most of the available models online or as backup, is that these models actually see the hospital as an overall process, and they are not stopping in what is the behavior of medical devices. So we know, as we can see, that the main impact points that we have are heating, electricity, infrastructure, and catering. But we are not really seeing what is happening with medical devices. So in their model, they were only covering imaging diagnostics, as it is supposed that is the area that has a higher consumption of electricity. But it does not necessarily mean that it's the medical devices that are that have the higher impact. So our question was, what is happening with medical devices? What is the level of impact that they generate? So for proposing a more accurate model, and for being able to create then a policy to reduce the impact generated by the hospital, we should separate the analysis in 3 points, on 3 hotspots. The first one is to evaluate how is the hospital working operationally. So we will try to evaluate how much taxes we are wearing, how much water we are wasting, how much if we are using electronics or we are still using paper. Then we would have to evaluate facilities to see how much electricity we're consuming, we're consuming, medical gases generations, and everything that is related directly to the facilities. And then we would have to put our focus on technology. what kind of technology we are using, is it or not sustainable? So, then, which are the parameters that should be evaluated in an assessment like this? These are the 16 parameters that the European Union has set it for a complete environmental evaluation. And here are highlighted the ones that are actually relevant for medical devices. So, to evaluate all the areas in a hospital and to determine which are the ones that have the highest impact, we decided to reduce our evaluation to the electricity and gas consumption, just to see where are the highest consumption in the hospital. So we can see in this graphic that it is in the surgery room, in the operation theater. So we are going to focus on that point. Here we have a list of medical devices that we can find in a general purpose operational theater. And it is well known that as this area takes the third part of the complete budget of a hospital, and the anesthesia unit is the one that actually generates the 50% of the emissions of this area. So this could be the evaluation that we could perform in this specific device. We're going to evaluate the impact of all these categories and check it, and it will vary depending on which gas we are analyzing. So we can see that there are some of them that have higher impact than others. Then, for some parameters, for example, human toxicity and non-cancer, those are values taken from the exposure limits. So it is related more to the occupational values than specifically a parameter of impact. It's more like how much, what's the impact directly in the health, not as much as environmentally. So, in the evaluation, we can see that the cost per hour does not necessarily mean that we have, to reduce the cost per hour of the use of these different gases does not necessarily mean that we have that is directly connected to the emissions. So if we wanted to reduce an operational measure that we could take is just to replace the gas that we are using, and it will not directly impact in the final cost. So as you can see, a good policy that we could create is just to replace the type of anesthesia that we are using. In fact, in Argentina we do that because it's cheaper, but it's a good measure, and we are actually reducing the emissions that we are generating. This is another possible proposal where we could do a facility adaptation, using, for example, the dynamic scanning systems, trying to collect all the anesthetic gas not used and dispose them, or in this case, this is an innovation that is from a company called Gas Recycler, that they are actually collecting the non-used gas and trying to recycle it for using it again, as only the 1% of the anesthetic gas is metabolized by the body when you are in surgery, so the rest could be collected and reused. So that would be a good impact measure as well. So at the end, if we could evaluate all the parameters, we could try to find focus points where to reduce them, and that could actually lead us to reduce the final consumption of the resources that we're using. So, what we have seen is that, in general, the main impact points that we have in our installation in our hospital are going to, our main resources are going to go to electricity, to HVAC, but to being able to reduce this when a hospital is already operating is very hard, and it would lead us to have a very high economical effort. But all these facilities are actually planned around medical devices, around the final use that we're giving it. So we can focus our policies in operating hospitals in reducing the impact to medical devices. So some of the points that we could take in consideration is to evaluate how they are impacting, which policies we could develop, and adapt new technologies, improve the management plans, or improve the sustainability during purchasing. Most of these politics will probably incur into primary erogation of money, but it would lead to a long-term saving. And for new hospital projects, it should be considered sustainability as a key part during the very beginning of the concept, so we can stand on in a more efficient basis. Finally, to propose a future lines of work, it would be interesting to start developing or to complete this model and try to gain field experience in this database collecting. So we could also support hospitals in the development of the model and to run it, so we can evaluate the carbon print that they are generating, and finally to dump all this information in a collaborative database so we can all use it and we can all improve our policies. So, thank you.
Thank you very much for a very lively and interesting presentation. I'm sure there are some questions from the audience. Yes, please. Oh, I thought you were. Oh, maybe. Go ahead.
Wonderful presentation. A question. In your analysis, have you compared any suppliers of anesthesia units in order to see which one is more efficiently or more eco-friendly for the ecosystem? You have arrived until that, or you are?
No, we evaluated the different anesthetic, trying to see what is the higher emission per hour using different anesthetics. But there is information regarding to that, so if the model can be extended and we can go further to that evaluation. That will be the next step. Yes.
Any further question? Yes, Yaketi?
If you ever consider different kind of framework of analysis, considering different kind of families like diagnostic imaging devices, or other kind of
yes, what we wanted to see actually is how can we reduce it by areas, right? So that was our first idea. The thing is that we actually need to manage a lot of database for that. So that's our proposal is to try to get to that point, to gain all this information. There aren't a lot of hospitals that actually collect this information, and that is our first point to jump. So the ideal is to work on this model and go further and try to collect information from several hospitals and from different profile of hospitals. I think that for being able to create actually a reduction and an efficient policy, we need to see how they are behaving. where are they spending more, why they are spending more. Is it because they don't have access to something, to a better technology? Is it because we are in situated geographically in a place that actually consumes more? So that is the idea. But for that we need to collect all this data, and that is our proposal, to try to create this collaborative database for getting all that information and trying to solve this problem.
I have a question myself. Oh, sorry. Please go ahead.
Thank you very much. It's very nice presentation. I am very curious and also interested in, probably I have to see you later after this session, but you know, in hospital facilities where I come from, at times some of the surgeons have some suspicion that they have some leakages of anesthetic gases, even within the surgical room. May I know if there are some tools that you use in monitoring such situation, or also getting data from the emission of these anesthetic gases?
The best measure would be the scanning system, but the dynamic one. The dynamic scanning system will allow to remove all the anesthetic from the remaining anesthetic from the use of the anesthesia machine, but the dynamic unit take it makes the vacuum and take it to a specific room, and as it is dynamic, it is working by a ventilator, so it will reduce the electricity that you have to use, and at the same time the disposal of the anesthesia would be out of the room. What they were presenting, that innovation that I showed, they actually collected back the anesthetic. So they are working on the FDA approval for actually recycling this anesthesia to be used again. But if they wouldn't do that, you at least are collecting back the anesthetics, so you're not emitting it to the environment, and that is the key point, not to emit it.
Okay, thank you. My question has an answer which can be summarized by two numbers. In engineering, we very often have efficiency numbers, efficiency percentages, like a thermoelectric plant has 38 or 40% efficiency or so. Your company specializes in making better the efficiency on a sustainability ground. What is the objective you can hope for in two situations that you mentioned? One is a already running hospital. Your intervention in maybe 5 or 8 or 10 years can get to what kind of percentage are you aiming at in the reduction, for instance, of electrical power or megawatt hour being used per year? What is the goal of your intervention? Is it a 5 to 20% reduction, first of all, in a already running hospital, and second, in the planning of a new hospital, which I think is the most interesting part of your work, is by interfering or doing an intervention before the hospital has been built, which we have some experience in that already. But are you aiming at a 2%, 5%, 20% reduction in some of the parameter of waste, if one can say? And what is the difference between your intervention is in an already existing hospital and in a to be designed and to be constructed hospital?
Well, for already operating hospitals, that would depend on the profile. So I think that, I don't know if I can give you an exact number, but the idea is to actually gain to that point, to be in that point. So, as every, we have, for all these years, we have never actually taken into consideration this point, never. So, nowadays technology is helping us to lead to that point. I'm not sure if I can give you an exact number, but getting to change the processes that we use will go to a better place. But also changing the technology that we are using, reducing, we were working in assessment of sustainability procurement processes, where we were trying to show that there are some specific parameters, especially when we are procuring from long distances or not. All that impacts in the final numbers that we have. So it's very extensive from where we set the boundaries of the model. It could be the main point is from the transportation to the final point of use of the hospital. I can give you an exact number. And for new hospitals, the key point is to plan the facilities, and that is the point of reduction. For example, in a hospital I was in Córdoba, we could reduce with the use of solar panels, we could reduce the 20% of energy used, electrical energy used. We were self-sufficient in that point. So it's a interesting point.
That's the number I was asking for, 20%.
But that was planned from the beginning.
Yes, that's the way you convince your clients. Otherwise, you cannot sell your work.
Okay.
Thank you very much. Let us move on then to the next presentation. We are calling upon Mary Vidal from Peru and Jessica Coronado, whom I understand is not present.
Good morning, everyone. I'm missing something. It's not. Good morning, everyone. Buongiorno, bon dia. I'm sorry. I am Mary Vidal. And today I am going to present you how clinical engineers have a key role in healthcare technology management and projects, and why is it important. And this is, This work has been done with Jessica Coronado, who is the leader of healthcare projects in clinical engineering department, and myself, that I am the manager of clinical engineering for AUNA Group in Peru, Colombia, and Mexico. First of all, let me tell you something about the company I work for, if it is work. Can you help me, because it's not working? Yeah. Okay, thank you. So AUNA is a group of medical center and private hospital, a Peruvian group that started in 2008 and now has more than 28 facilities in Peru, Colombia, and Mexico. Our vision is to be the reference and the leader in Latin America with a healthcare focus on the patient. How are we going to do that? We have to transform the healthcare sector in every country we manage. Currently, we have facilities like more 2,000 beds. We have more like 14,000 employees, and I work there since 2010. When I arrived to AUNA, I was one person, one engineer. We managed 36 medical equipment with an investment of $1 million, and now we became this. Can you help me, please? Because it's not. Okay. Here are some pictures of the facilities that we have in Peru, Colombia, and Mexico. For example, we have in Peru the Clínica Delgado, that is one of the top hospitals in high complexity. We also have in Colombia Clínica de las Américas, that is located in Medellin, focus on primary care and oncology, and also we have some facilities in Monterrey, Mexico. So, Auna Clinical Engineering Department, we have the mission to manage all the healthcare equipment, medical equipment in each facility in order to guarantee patient safety first, in order to guarantee the continuity of the operations, to make that the user like the technology they use and they are very happy with it, and also to be profitability. Okay, we started being one person like 13 years ago. Now we are 63 people in 3 countries. We manage more than 15,000 medical equipment with an investment of almost $550 million. And how do we manage to do that? Because we have a centralized model, that type GLO for global, because we take advantage of all the best practices around the world and we adapt them into each country, each regulation we have per country. We also have this model that pilots that have is in procurement, initiative and projects and operations. I am going to talk about more focus on healthcare projects management area, which is the topic today. But as we think about clinical engineering, we think we are technology managers. Why technology managers? Because we add value to healthcare organizations. So in the area of healthcare project management, until now we have implemented 5 facilities, 4 in Peru, 1 in Colombia, and sooner we're going to implement 1 facility. The leader there is Jessica Coronado. How do we start? First of all, according to my experience in Latin America, the clinical engineer has like an active role in healthcare projects management. We commonly participate in these 2 stages, building and implementation. But we are not have like an opinion or an active role in what is evaluation and designing. It is really important that we have a voice and we have a key role in evaluation and designing, because we are capable, we have the knowledge, we have the experience. But we have to start. So we start doing the basic thing. What is doing the basic thing in healthcare projects? Deliver information related to medical equipment, to pre-installations, to give information, so the equipment list, what do have a hospital of 300 beds, what services has a hospital of 600 beds, for example. Then we came into this thinking, if I want to make a positive change in the profession, not only in Peru but in the region, do I should stay in the basic activities? So I just contribute giving information about the installation of medical equipment, doing a list. Can we close to the C-level? Can we be part of the decision-making table if we just focus on the basic? The answer is no, of course. That's why we move forward and we start focusing in what adds more value. What is that? First of all, we're starting to make a proposal of the distribution of the hospital. For example, if you want to implement diagnostic medical imaging, it must be close to the emergency department. But for example, a mammograph has the be close to the CT scanner, CT MR. Why in the first floor? Why not in the top one? So we start giving some proposal for the location of certain specialties. Then, of course, we have to take into consideration the patient safety and also the patient workflow. Then we start to taking responsibility for the capital expenses. I am not just an actor that gives some list and is not responsible for the budgeting. So we take into account the budgeting and said, if this hospital is going to meet these certain requirements, it costs like $100 million. And I am responsible for that number. The third thing we did was that we designed a prototype of our model according to what type of hospital we need per certain facility, per certain country that we are going to meet. So we did that, and we evolved from doing just this part, from doing these facilities, from making some proposal of specialties and other ones. Now, in these almost 13 years, we have achieved what? First of all, we designed area from scratch that currently add value to AUNA and is part of the decision-making process. Everything investment, everything consideration related to medical equipment, we are in the decision-making table. Second, we could transfer the knowledge or the experience. The knowledge has to transcend the people, has to be in the organization. So we do procedures, we document all we have gained, and also we use them to optimize the flow. What else we did? We changed the paradigm that we are just engineers who maintain or who repair medical equipment. Here in the healthcare projects, we have a key role, and we have to struggle for that, because I think that we can make a very good, successful project if we think like a manager. The fourth one would be, it's important that if you want to implement some facilities, you have to have a dedicated clinical engineering department or area for doing that. Otherwise, the results will not be as good as if you have it one. Finally, some takeaways. It's important always listen, learning, updating. It's very important to listen to the physician, to the user, because if you understand why they think, why they want, you can make effectively proposals. Second one would be, in a project, as a more below, everything can fall apart. So we have to manage several contingency plans, because everything can fall apart, but you have to be ready and be prepared for that. A third one would be focus on the solution. I remember that in one project I have to work as a people who clean something. I am a clinical engineer, but I have to clean something because I was focused on the solution. So you have to focus on the solution, and you have to make it work. Finally, you have to think that everything is because of the team. You have to work as a team. You have to share the knowledge, transfer the knowledge, delegate the responsibilities, because that's a very good way that your people can grow with you, and the department also can grow. Finally, remember, you don't need to be a leader. You don't need to have that title to do leadership things. You have to make it work, and you have to make it work always. That will be all. Thank you very much.
Thank you very much for a lively presentation. And look at the photo gallery we have here. This is something to look at. The several settings of court you have worked in. Any questions before mine? Yes, questions? Do you also work with national or state hospitals, or is it only a private hospital initiative?
No, it's only in the private sector. AUNA belongs to the private sector, so we don't meet. We can have a public hospital because of the regulation and the healthcare system.
Because it would be interesting to have comparisons and comparative work, in the sense of sort of justifying some sort of expenses that are maybe sometimes a lot more expensive, if you like, in the public sector with respect to the private sector. In a position, one usually thinks that public health sector is cheaper and spends less and all that sort of thing. It would be interesting for you and your company to try to gather data and have some sort of comparative study on efficiencies, cost, time, etc.
That's a wonderful question, Franco. I forgot to mention that I am a president of the Peruvian Association of Clinical Engineers. So then we have engineers from the public sector, for the private one, and we do several studies, and we can, all the knowledge that I can gain here from this conference, I come back to Peru and do like a webinar and can transfer all this knowledge and all this experience, because not all the people has the money, has the time to participate of these events. So as a UNA, as a Mary Vidal, I like to do that, and I do that all the times.
Okay, thank you. Any other questions? Don't be shy, please. Yes, sir.
Yeah, very good morning, ma'am. So, as you mentioned that your key thing, like one of the key things what you do is that you listen to your customers, you get the feedback. So, I'm just curious to know that how much percentage of your revenue goes into the R&D to innovate a new medical devices or to get into your process more efficient. So, how much of your revenue, percentage of revenue, if it is like anything allocated for your R&D to improve your efficiencies or your devices or your customer satisfaction activities, if there are any?
Okay, I don't know if I understand that
R&D,
question.
investigación y desarrollo. ¿Qué parte
Research
del...
and development. As AUNA, we have a foundation that is AUNA Ideas, but it has its own budget. It's not depends of the revenue of the company, of the corporate. It has a separate sourcing. Okay, but as clinical engineers, or what we take into account for replacement of the medical equipment, more or less is 5 or 10% of the revenue are for medical equipment investment, more or less.
Does that answer your question? Yes? Okay, thank you. Any other questions from the floor? Suggestions? Well, then, thank you very much, Marie. It was very, very, very nice presentation. Now, we're calling upon Engineer Giulio Iacchetti, please, from Italy.
Hello everybody. First of all, thank you for the invitation by Scientific Committee. I'm Giulio Iacchetti. I'm Health Technology Manager, Innovation Manager for Medipass. That is part of LGI Group.
Speak up, please. Speak up.
Sorry. Okay. This is the team by which we developed the project. Just a little introduction of Medipass is a company that is focused on delivering clinical, is a clinical provider for diagnostic and therapy for patient in clinics that are by our own and in partnership with public institutions. For this kind of project, we selected SurgiQ. That is a company that I would say is a sort of engine that is behind our RIS, Radiological Information System, and is specifically focused on AI engines related to scheduling in general. And ILCO, that is the company that is provider of the RIS, Radiological Information System. The project is The project is focused on a PET-CT center. We have the process in nuclear medicine, the process of delivering the diagnostics. That probably is the most complex one, considering the fact that the injection is a moment in which you have to fit the prescription of a nuclear physicist. that is not only related to a certain activity, but is also related to a certain timing. So you always have to be on time. That is a general principle, that is a principle of justification, in which you have to consider that in general, a radio tracer can create damage inside the body, and so the justification principle states that you have to consider the benefit of a potential diagnostics related to the damage that you for sure you are creating. This is a key point considering the timing, because it's always very important to be on time in this process. Very complex one, considering that our site is a production site with a cyclotron. Okay. We started considering the fact that we have a high number of diagnostic protocols, very large number of diagnostic protocols, like 15 different diagnostic protocols for different kind of tracers, and as an output in this scheme, I would say we have a strong variance in duration of each step in protocol. So we consider this like first time we consider that like obviously like a weakness of our organization, and we try to understand more how we could exploit, I would say, this kind of weakness. Really, we try to take this variance as an output, and we tried to insert this variance in the schedule. This was the mission of the project. I'm so sorry again. Now, when you have complex context, like in fluid dynamics, you could analyze it in a Lagrange approach, in which you consider a single particle doing the movement, or you can consider the Eulerian approach, in which you consider the field of, for example, of speed in different timing. We can consider a Lagrange approach, considering each patient and being focused on each patient during the path, the clinical pathway in the organization, and an Eulerian approach, considering all that is around. We try to have this kind of approach, and in this way we had time modeling for each diagnostic protocol, considering for each step an average and a variance of each single step, and in this way we are focused on each single patient. On the other hand, we consider all that is around, and so each constraint and the requirement that we would fit. The first one of the requirements, obviously, is that the tomograph is always with the patient on. So there is a coincidence in the end of each exam and in the starting timing of the other. Now, to understand more, I try to make this slide. One of the weakness, the source of one of the weakness, was the fact that the scheduling was with a fixed step gap, I would say, from the starting time of each single slot. We have typically fixed time. This is something that create in the organization a source of variance, since that for each single protocol that is not the same, is not always the same for each patient, the organization have to slow down in certain time and in order to accelerate the step procedure for the patient. So it's something that is an efficient, not for the patient, not for the organization itself. Now, in this in this example, we would just imagine if just we try to rearrange in a different way, considering the two approach, the Lagrangian approach and the Eulerian approach, considering the requirements that we mentioned before. As you see, the patient number 2 and the patient number 3 that in a fixed slot was with the time gap with that we decided, considering the fixed slot framework. In the other part, in the new way of scheduling, the patient number 2 and the patient number 3 are on the same timing, and in this way we can have their exam one after the other. This is not just related to a new way of scheduling, but is something that is related to the fact that we are trying to take the timing, the real timing of the organization, and customize the scheduling considering that. This is something, this is something that fits two pillars of lean thinking. Is impossible in nuclear medicine to have a real, pure, I would say, pull approach. But really, in this way, you do the best for the patient on time, considering like the patient was just arrived in a clinical center. And on the other hand, again, the timing is the timing that the organization itself give us. The performance that we measure is the historical performance. So they can vary in the future, and this will be part of a new way of scheduling. As we mentioned, is a sort of dynamic scheduling. So it's something that is fed by the historical data, considering the new way of scheduling. Okay. In conclusion, the advantages is not just related to nuclear medicine. It's related to each single diagnostic family of services, pure diagnostic services, in which we have many different protocols for the patient. Is something, and this is strongly related to nuclear medicine, that gives us the chance to have an automatic scheduler. If you have a cyclotron, it's very important to have something that very quickly give you the chance to reschedule and don't lose any minute, considering the decay of the tracer. It's something that can be useful for the enterprise quality system, because this session is about impact and performance. So it's strongly related to the quality, and I would underline that is not for more to make more production. It's something to spend in a better way the time to the patient. This is the goal of the because the organization do the best that they can in the time that they can. Then doesn't have to slow down or accelerate. It's something that is a key point. This is something from my point of view very fascinating. It could be also a way in which we could make some scenario in implementing new technologies in this case in the PET-CT center, considering, for example, automatic when you have to produce a single fraction, you have to deliver a single dose of tracer. There are new devices for the automatic delivering, and we managed to analyze the impact of this kind of technology inside the organization, considering new timing in each step. Thank you.
Thank you so much, Dr. Iacchetti. Before proceeding to the questions, we are
so sorry.
very numerous.
There's a last...
Last slide,
yeah,
please show it.
yeah.
I have an announcement to make before
I'm so sorry.
the questions. We're going to take a picture of the group, and we're going to have a presentation, a recorded presentation before we leave. But first of all, is this your last slide?
This is the one. Thank
Okay.
you.
So let me make these two announcements. Just after this presentation, if we don't have that of Mr. Glenville, we will have a group photograph of all of us in the room, and we will see, prior to this, a recorded presentation by the group of Niranjan and Mohammed Sadul before that, right? So, questions for, no? Yes, please.
Question?
Yes. Any questions? Yes. Sir?
You have mentioned about the cyclotron being taken into account. Cyclotron have to deliver dosages to different other hospitals, but if you are working only through one hospital, how do you consider its dosages to different places? Also, the cyclotron delivery depends on the demand of dosage per week or per month, depends on the location.
Okay. No, in this case, the cyclotron is just for only for one hospital, not for the distribution to other hospitals, because it's a research hospital. Generally, we consider the for it's difficult to, it's very complex way for the program of the cyclotron. You have to consider the prescription of each patient that is based on the prescription, obviously, of the nuclear medicine physicist. You have to add each single dose, and this is the driver by which you can consider how many hour you have to set for the production. Is a nuclear reaction, obviously, so you have to keep on having this kind of nuclear reaction to reach a certain amount of radioactivity. On the same time, you have a sort of I would say flat. It's not a process that can keep on having the amount of radioactivity that you would, because in the you have a saturation, a curve of saturation for the production. So generally you have not more than 2 hour, 2 hour and a half, considering the energy of that kind of cyclotron. That is 19 MeV.
18 MeV, it must be 18 MeV. 19?
Yeah.
Okay. I have another question.
Yeah.
Have you...
Consider that discussion one-on-one afterwards, if that's okay?
Yeah.
That's a great question.
Okay. Okay.
And
Two of you afterwards. Because maybe not everybody's interested in cyclotron, everything.
I think, okay.
And I'm going to
Is that all
say,
right? Okay.
I'm going to say,
Yes.
Franco, in
Yeah.
30 seconds about Dr. Glenville Liebert, who's from St. Kitts and Nevis, which is a Caribbean islands, and a physician and a friend to CED, a collaborator of CED. And what his presentation is about is creating a database for people with disabilities.
Mhm.
And you know, that meets so many needs. I mean, clinical engineering is very connected to the rehab business, but that particular presentation is about creating a database and how that's really helping rehab in the Caribbean islands. That being said, though, I think we could move on to your last recording.
Thank you, Tom. I wanted to thank and comment on Dr. Iachitti's presentation. Just in a second. I wanted to point out for the audience that we had 3 presentations on efficiency of clinical engineering in hospitals. And the third one by Iachitti also had to do with this, efficiency. And one very important topic was that he not only mentioned economic efficiency, but also the efficiency in terms of patient time and patient experience, which is a real big challenge in clinical engineering. Not only money, but also personal experience of the patients. My question would have been, how do you value or put a numerical figure to patient experience, to use it as an artificial intelligence topic? What do you use, a number or what?
Yeah, I have the question. Strange that I have a question. I have an answer. Really, the topic for the patient, for the sensitivity of the patient, is the variance. It's not the average. It's very strange. You can tell to a patient that the exam, like in this case, we make something like more than 5,000 exam per year per thermographer, so it's very high volume. You can tell the patient that the exam is 3 hours long, and it's something that the patient accepts, like the effort of the organization for their health. When the organization has variance, the patient feel uncomfortable, because the organization have to stop, have to create stacks. The patient doesn't feel like all are around him or her.
Perfect. Thank you.
But he is part of a stack, and they have to consume this.
That's clear, very
And
clear.
this is something that the patient feel.
Thank you.
Okay.
That's really interesting. We must move on, and here is the movie of the colleague. Please, go ahead.
Good day, everyone. My name is Carmen Eloisa Martinez, and today, on behalf of the Clinical Engineering Department of the Sociedad de Radiología Española, I will share with you our work entitled Consolidation of a Clinical Engineering Department, a 10-year perspective. Our Clinical Engineering Department was established 10 years ago, making it one of the oldest in our city, San Luis Potosí, in Mexico. This department is integrated by 11 engineers named on the screen, who with their constant work and commitment to the profession have achieved the hospital director's confidence and the positioning of the department as one with the more operational capabilities in the region. San Luis Potosí is a city located in the center of Mexico, with a population of almost 3 million inhabitants. The city has only one university offering a bachelor's degree in biomedical engineering, the Autonomous University of San Luis Potosí. This 5-year bachelor program started in 2010, and from 2015 until 2020 has graduated 174 biomedical engineers. Furthermore, San Luis Potosí has only 10 clinical engineering departments, each one formed by approximately 3 employees, as well as some vacancies for the training of students. Given this context, we have the problem of a lack of awareness of the proper management of health technology and the role of clinical engineering, causing a delay in the use of innovative and appropriate tools, impacting in the practice of clinical engineering without the necessary resources. The department is started with a 2-engineer team focused on administrative work and the supervision of medicine done by external companies. After 10 years Thanks to the identification of the needs of patients and healthcare staff, like physicians and nurses, we are now a well-established department capable of executing diverse activities, and with a voice in the decisions made by the hospital directors regarding medical equipment and hospital facilities. All this means to have a modern hospital with functional and cutting-edge technology. La Veneta Luis is one of the private hospitals with the highest capabilities in the technology for the diagnosis, treatment, and rehabilitation of patients in the city, providing healthcare services to 300 patients and performing 250 surgical procedures per month in 2022. Furthermore, the hospital has 18 medical equipment, of which 52% corresponds to life support equipment distributed through the 23 different areas in the institution. Our department is focused on the adoption of policies and process oriented to the continuous improvement of the knowledge and capabilities of our members. In this way, our department is divided into 4 areas of expertise: device engineering, training of engineers and healthcare personnel in the correct use of the medical technology, pack administration, and technology assistance to physicians during surgery procedures. From a 2 engineering team, we are now 15 engineers covering 24/7 clinical engineering needs at La Sociedad de Medicina Española. Also, it's important to note that from these 15 engineers, 4 are students in training and 11 are women. Each team task has been involved to ensure the highest quality in service in the overall work performed by the department to contribute to providing the best healthcare service. To achieve a well-structured and standardized work, the CE department has established different strategies, such as checklist notes, use of formats, continuing education, staff supervision, use of communication platforms, schedule assignment, delegation and delimitation of activities, use of CMMS, process well defined, among others. So, here we share with you some of last year's teamwork tools. On this graph, we show the surgical procedures assisted by clinical engineers during 2022 and 2023, observing an increment in surgical assistance in comparison with last year to the constant promotion on good practice among physicians by the CE departments and the reliability of engineers by medical staff. Regarding preventive and corrective medicine, in the past, almost all the medicine surveys were performed by external companies. Now, the majority of them are managed and executed by the CE department without needing external assistance. This has been achieved through the knowledge of the technical operations and use of medical technology, continuing education, medicine's process well defined, and the generation of formats and the use of metrology equipment. Our training program was established in 2014 for many biomedical engineering students interested in developing a career in clinical engineering. In this theoretical practical program, students have the opportunity to actually participate in day-to-day activities, gaining invaluable knowledge and experience. Since this creation, 29 students have been enrolled in this 12-month training program. After completing it, all of them continue successfully developing their careers in the clinical engineering field. Furthermore, 12 of them received a job offer to keep working in the hospital, now as employees. Another milestone for the CE department was our response during the COVID-19 pandemic. Our hospital was the first one to diagnose a positive case of COVID-19 in San Luis. The current part of the hospital design provides healthcare in this regard. In consequence, the CE department was in charge of developing a new hospitalization floor focused on COVID-19 patients, including the modification to the facilities and the installation of medical technology equipment needed. Also, the CE department installed a closed-loop telemetry system for a real-time patient monitoring and managing the acquisition of transportation capsules for infected patients and medical equipment, such as ventilators and high-flow humidifiers. Also, the CE department developed the protocol for the disinfection and maintenance of medical equipment during the pandemic. During this year, our clinical engineering department, through their constant work and commitment to the profession, has earned the trust of our hospital directors and the right vote on hospital administration's medical technology division. This has been achieved through the continued improvement efforts of our department, focused on the work of our capabilities and knowledge, as well as tax diversification, tax designation, and teamwork. Finally, through our training programs, we have witnessed the importance of our role in the development of human resources in clinical engineering. Being aware of the responsibility we have to increase patient safety in our city. Thank you so much for the opportunity to present the work at this Congress. If you have any questions, please reach out to this email account. We are very happy to receive your feedback and collaborate with you to keep growing our CE department and the awareness of the clinical engineering profession. On behalf of our team, thank you.
Well, thank you very much. Let's see then the last, any comment? I mean, we already commented this. Yes, please, madam. No? Let us then proceed to the next.
Have a good day for all. Thank you for joining me today to discuss a pressing issue that has deeply impact on life of women in Sudan: the effect of war in healthcare technology. My name is ICEHTMC. I'm a biomedical engineer, and I'm presenting on behalf of Sudanese biomedical engineer Emergency Room, a part of a steering committee of biomedical engineer syndicate in Sudan. In the start, Sudan, a nation of 47.7 million, faced a critical situation due to the war that erupted in Khartoum in April 2023. Approximately 20% of population reside in capital, where now many healthcare facilities have gone out of service. The majority of specialized medical centers and skilled professionals like biomedical engineers are in Khartoum, leaving other states with the limited resource. It's worth noting that only 3 of 17 states have a specialized medical center. This challenge have adversely affected healthcare technology. As a result, the healthcare system is about to collapse, with highly concerning humanitarian and economic conditions as well. Let's talk about challenge and problem. Remarkable number of medical devices are vanished due to the bombing or gun firing. More than 125 hospitals in Khartoum are currently out of service due to shortage of electricity and water, leading to 60% decline in medical service across Sudan. Also, improper system shutdown or storage as a result of war cause major malfunction in medical device material part, damage in sensor, valves, tubes, and so on. Electricity system failure affect sophisticated medical device such as MRI, bed system. Let's talk about MRI. There is 13 systems in Khartoum have suffered due to electricity failure. This leading to loss of 75% of MRI system in Sudan. Also, some of donated medical device via international humanitarian organization did not achieve their intended purpose due to issues related to technology selection, staff training, logistic, and after-sales service. Lack of security has led to inability of biomedical engineers to manage maintenance, corrective, or preventive maintenance. Increased number of displacing people cause overloading in healthcare service as well as healthcare technology. Let's talk about financial estimate. Initial estimate indicate loss of around $60 million for medical device asset and additionally 35 for rehabilitation expensive. Immediate healthcare capacity exchange and improvement in states require approximately $130 million. To solve this challenge, we put some objective. The general objective: improve the flexibility and efficiency of healthcare system to enhance its ability to respond to emergency. Specific objective: enhancement of healthcare system functionality and efficiency to improve its ability to respond to ongoing emergency situation. Develop the capacity of engineering and medical staff in subjects such as disaster management, critical supply chain, technology updating, and optimal use of device and technology. Establish effective national medical device registry system for better coordination, ensure swift response to emergency, and better cooperation among all stakeholders. By achieving this objective, we can expect the following results: establish an integrated health system flexible to emergency and disaster. Enhance the healthcare service by increasing efficiency of healthcare technology, sensitivity of medical consumable by implementing a supply chain plan, and availability of competent biomedical engineering staff in various domains. In the end, Sudan healthcare system is facing a critical situation. Hospitals are shut down, medical devices are manufacturing, and services are strained. The estimated financial loss and rehabilitation costs are huge. Urgent action is needed to establish an integrated emergency health system, ensure sustainable health service, and train skilled biomedical engineering. Cooperation between nation and international partners is crucial to rebuild Sudan's healthcare infrastructure and service swiftly. And then, thank you for your attention.
Well, thank you very much. At a distance to Aisha Mohammed from Sudan. Concluding remark on this is that, of course, we are working in universities, in companies, in hospitals. We are also living in a global world, and we must definitely, from our own trenches, do something about peace, do something about against war, which is it goes against history, goes against human evolution to have so many wars and so many nasty things happening all over the world. So let us take the flag of this clinical engineering major efficiency with our human compromise and human project of life. And with this in mind, let us join all in the middle of this room for a joint photograph, if you like. Let us go.
बाहर ही है, एक बार बुला लो क्योंकि he spent his time on it. कुछ चल रहा है यहाँ पे, बहुत लोग आ नहीं रहे हैं होटल में. अरे वो बुला के अगर कोई आया तो चलेगा. हेलो हेलो हेलो. Okay, let's see.
Slight changes with the next presentator. excuse us, we need to start the next session, B3. Pekhatan is going to be the chair. I'm co-chairing just for the first presentation with her. He told us it's okay if we sit here. It's fine, it's fine, don't worry. I'm glad to tell you that in the first presentation, I am presenting the clinical engineer responsibilities to sustain their global clinical engineering journal. Oh, it did work. I'm Kalliroi Stavrianou. I'm Global Clinical Engineering Journal Manager. I'm also the Manager and Secretariat of the Global Clinical Engineering Alliance. And Yadin David is our Editor-in-Chief. I'm sure you all know Dr. Yadin David. Yeah. Okay. So let me introduce you the journal. The journal is a Diamond Open Access journal. It has high quality peer review and editing processes, and this is why it's called Diamond. So it's a high quality journal, and it eliminates the articles processing fees. So it's offering both authors and readers free access. Sorry. Really sorry about that. Okay. The journal provides a forum for clinical engineers in order to exchange knowledge, best practices, and research, and therefore help to advance the field of clinical engineering. The journal covers a wide range of topics, including education, practice, and research, and is open to submission for all over the world. Therefore, it's global. The journal is peer-reviewed, indexed by Scopus, and is free for authors as well as the readers. We are stressing that many times, as you can see. Placing Global CE Journal among the preferable journals for exchange, knowledge sharing, and engagement of clinical engineers across the globe, as it is an affordable option for authors who are looking to publish their research in a high-quality journal. The goals of the journal are, of course, to advance and disseminate knowledge, as all journals do. Furthermore, it's aiming to promote professional networking among practitioners, stakeholders in academia, industry, government, and other decision makers in healthcare field. To promote education, training, and ethical professional practice among the members of the clinical engineering community, and to become the preferred international scientific journals dedicated to healthcare technology and, more importantly, clinical engineering. The journal has published 5 volumes so far, 4 special issues. I'm happy to tell you that just today, a few hours ago, we published the 5th special issue, which is the proceedings of this Congress. And I hope you all have a hard copy if you are on site. And those that are not on site can now access it online and download it. And we are very proud because this Congress is among the few Congresses that publish their proceedings before the Congress even ends. The International Editorial Board has, as we said, Editor-in-Chief Dr. Yadin David, and is representing all the fields of engineering, medicine, academia, and WHO. And you can see that all the flags here are the countries the editors are from. We have already published the proceedings of the 3rd and the 4th ICEHTMC, and today, as I told you, we published the 5th ICEHTMC proceedings that you all have a hard copy of. We have updated the website by adding a section of the most read articles, and we have added active links on that. And it's always updated when a new issue is published. Those numbers are always updated. Plagiarism is now detected through the dedicated software of ICEHTMC, which is used by the editor-in-chief. And as I told you, on May 2023, Global Sea Journal has been accepted to be indexed by Scopus. And this was a major achievement that we're very happy about. So let's focus now to the readers' responsibilities. We want our readers to submit manuscripts and review papers, because we are inviting you to volunteer to serve as reviewers in the area of your expertise. We want you to promote the journal to your colleagues, to share articles and to encourage novices to write more about their works. Please write feedback about the topics you would like to know and read more. This will inspire us to focus on even broader topics. Please stay updated and suggest new subjects the journal should cover. Report your ethical concerns if you identify plagiarism or unethical practices. And last but not least, active participation and responsible behavior as a reader can contribute greatly to the success and impact of our online journal. So please be more active, participate more in the journal. In order to increase our global audience, we're making great efforts, and we have the Chinese translation of 4 or 5 volumes so far. Can you help me with the next slide, please? Thank you. So our colleagues in China will be able to read this in their maternal language, and this might be extended also to more translations. Thank you very much. I'm happy to answer any questions you might have.
Yes, I think I have a question, Kaliroy. What is the goal in terms of number of papers you're looking? I mean, as many as possible, of course, but do you have a sort of a program for the next 5 years or so about the number of papers to be published?
Yes, right now in the issues published, there are more or less 6 to 8 good articles, an editor's corner, sometimes white papers or engineering reports. Additional to that, we publish 3 or 4 times per year. This is the 4th actually, the special issue now, and we might have one more in December, the volume 6. So we are aiming to, let's say, 100 articles per year, because there is also the rejection rate. It takes a lot of time to process there is a double peer review, so we need time to give and take back all the review comments and the revisions. I think 100 is a possible number. Thank you for your question.
Thank you very much, Kaliroy. If there are no other questions, can we go to the next paper? I was told that all the presenters are here in person. Is that correct?
No, this is a recording.
Oh, so the next one is a recording. Okay.
Hello, and thank you very much for allowing this pre-recorded version of this presentation. I'm sorry that myself and my team couldn't be there with you in person. This presentation is based on a project which is ongoing, but we thought we would present to you the preliminary results of what we have done. The topic is to demonstrate the impact of clinical engineering on health systems globally. My name is Saba Hendricks-Krapels. I'm from the Delft University of Technology, and I did not do this alone. I have a team behind me, Dr. Lorena Aguilera and Ms. Shana Mulali as well. And of course, I would like to thank and acknowledge all the contributors from the global IFMB community who contributed their impact stories. Now, just to give you some background, it's no surprise to the community and the audience here that biomedical and clinical engineers play a crucial role in safeguarding the performance of hospitals and of other health providers. In fact, these news stories appeared around the world where clinical engineers were called the silent heroes or the unsung heroes because of the contributions that they made during the pandemic. But when we look at the literature, and I'm referring mainly to the academic literature that has studied health systems or health systems performance or how hospitals are doing, many of these empirical studies do not show how the biomedical or clinical engineering community or that function contributes to health systems performance. And that is a pity, of course, because even when we look at recent documentation from the World Health Organization, from the WHO, they have emphasized the role of engineering, of resource generation, of the health technology management function as an important function for health system strengthening. Now, there are, of course, difficulties in doing this, and that may well be one of the reasons why there aren't that many studies. But there are a few exceptions. One of them is a study that showed the relationship between performance outcomes of medical equipment technology management and the reduction in undesired events, so sort of a proxy for patient safety across 8 countries. And another study also tried to connect the work of clinical engineers to patient outcomes. So those are 2 studies that do stand out among the ones that we found. So what is our goal? So what we try to do is to identify the ways in which biomedical and clinical engineers have contributed to specific outcomes and impacts across different health systems globally. And I use the word contributed quite emphatically because we cannot say that this is a direct attribution, right? We cannot completely measure it. Of course, the studies that I showed in the previous slide did attempt to create a causal relation. But given the difficulties in collecting some of this data and the lack of sort of more controlled studies and evaluations, that is not completely possible for all the community around the globe. So we chose to just demonstrate how they have contributed through some qualitative stories and the survey responses that we gathered. Who we feel would benefit from this project and from this endeavor? Well, first of all, the global engineering community to demonstrate the crucial role that they have for health systems, but also academics who are studying how and why health systems resources contribute to good performance. And I'm one of those academics actually very interested in this, which is why I'm also interested in this particular study of ours. Also, policymakers we have identified as being beneficiaries to this work because they may want to think about how they invest in the clinical engineering function in their respective countries. Now, I'll talk about the method or the approach that we took. We released a survey via the network and got some responses back. We therefore collected a really broad range of responses that tell the story of the value that this engineering function plays in the lives of patients, in the lives of their families, and in the lives of healthcare workers and beyond. And we use what is called a theory of change model to categorize these stories, which I'll explain in a moment. And traditionally, the theory of change model always looks forward. This is they're also called sort of these program logic models that are strategy frameworks for organizations who say they have this goal, this is the impact they want to achieve, and how do we work backwards to get there? We used it the other way around. We actually went back in time and historically looked for studies to say, well, what did you do? What impact did you have? And can we collect some of those stories? But the framework is pretty much the same. We collected people's activities, which is the one on the left, We then asked how those activities led to outputs, which are the more directly measurable indicators of what happened. How did those outputs lead to slightly longer term outcomes? And ultimately, what impact did they have? And by impact, we are talking about general societal impacts primarily in line with the WHO priority areas for health system strengthening. And we gave them categories to tick in each of these, and also allowed for some free text for people to just comment on. We also were very, very keen that they didn't just fill out our survey, but that respondents also wrote their stories. So we gave them space to either share a link or write a vignette, as we called them, or story, so that they could really bring their value of their function to life. And we could then track that and put it into these categories ourselves. Now, the project is not finished. As you'll see from this slide over here, these are the results that we have so far. We've received 44 responses to date, representing 21 countries. Now, on the one hand, this is wonderful, and I'm extremely, extremely grateful that we've had so many responses. But we are keen to have more, because if we really want to populate that diagram and I establish what has been our sort of pathways to impact as a global community, we would like more representation from other countries, or even from the countries where we have responses, but perhaps different types of impact stories that we may not have received. So at the end of this presentation, this will also be an invitation for you to share our survey link with your network. So what have we collected so far? So from those responses that we've collected, all in all, we see that the left-hand box, or the activities which this community does, mainly relate to sort of installations and commissioning, these inspections. Of course, maintenance is a major part of what we do as a community, and then contract management, procurement, training, etc., etc., and then less so recalls and regulations for some of the respondents. And if we look at the other extreme of the diagram, so the ultimate impact of this community, well, many people tick the box of cost savings, saying actually we save money for either the hospital or the healthcare provider in which we're operating. We improved access to health, we improved diagnostics, hospital capacity management, but also because we released the survey shortly after or even during the pandemic, and we also had emergency preparedness as one of the impact categories that people selected. And we also allowed for people to say, well, what other types of impact that we haven't given you, and indeed the raised profile of the clinical engineer, whether it be through the hospital or nationally, was mentioned, so that led to policy influence and also quality of care was improved according to the respondents. Now, just to give you a flavor of some of these stories, I did say that we collected vignettes. A prominent example is indeed that one from the UK, where the clinical engineering function really had a say in procurement of personal protective equipment during COVID-19. And that means that they had a lot of policy influence ultimately. So sort of the voice of the clinical engineering function really came to life. In other countries, respondents mentioned that they got better recognition by either the hospital, but also at the level of policy making, sort of collaborations or recognitions by the Ministry of Health. Respondents also mentioned, I like this line very much from one of the respondents, that we kept life-saving machines running flawlessly during the pandemic. And another respondent focused on enhanced service delivery, improved clinical outcomes for all the countries or regions in their vicinity. So, how are engineers making a difference? Well, we're still trying to create that impact pathway. And even though I cannot share the final result, because I would like more responses still, I would like to show you how it is that we're creating that picture, that impact pathway, and how we're populating it. So this is just an illustrative example based on a selection of the responses that we've received so far. So this is what it will look like. So this is the image I showed earlier. The emerging impact pathway shows that you've got activities, they lead to outputs, which eventually lead to outcomes, and finally impact. And generally speaking, your activities and outputs are things that are more directly in your control. So you can influence them, whereas your outcomes are slightly indirect. You have less control of them because they may or may not happen. And your ultimate impact you'd like to see, but again, you have less control on that. And they're meant to be a bit more long-term. The kind of rule of thumb is that the impact is sort of 10 plus years from now. The outcomes is between 5 and 10 years from now. So the activities that we had listed and that we gathered are now on the left. And we wanted to see, okay, what was the mechanism, the pathway to get to the ultimate impact on the right? And we've begun to draw some of these links. So just to give you an example here, hopefully you can follow my mouse as I'm showing this. Engineers who were involved in procurement, for instance, might have created some local cost savings for their hospital or the health provider. And eventually this does lead to cost savings nationally. And actually, because of that, you also had a link to the influence in policy that they had, or the collaborations with the ministry. Taking user training as the activity, well, if you train more users of the equipment, then your output is that you have a certain amount of trained users. That's a no-brainer. But what happens as a result of that? Well, people reported that actually in some hospitals they were able to then measure reduced incidence, which I'm missing a line here, but then you could connect that back to care quality via the reduced incidence. So this is how we're drawing it. This is the picture that is emerging. As I said, it's not complete. I'll give you another set of examples here. Respondents who said that they were involved in maintenance, whether it was corrective maintenance or preventative maintenance. Also that actually had an influence on reduced incidence according to the way they measured it in their hospital, which also contributes to care quality. And you could also have ticked other impacts, right, that came from this. So one pathway does not mean a 1-1-1. Several activities could lead to several outputs and outcomes and to various impacts as well. And to give another example here, research and development activities that happen has produced some in-house products for some hospitals from the respondents we got, which means we had increased product availability, which again could potentially have contributed to. So the reason this is incomplete is because we're scanning those documents, those wonderful stories that we've received, and we're still trying to understand, okay, is this really a link? Is this a pathway that we can justifiably include in our pattern of activity? We would like to be able to say, okay, was this a one-off, or was this a type of pathway that we see across many other respondents or not? Because that will also help us decipher whether or not we can really confidently say this is an impact pathway that occurs often in many countries, or maybe it's just specific for that particular region or local context, which is also interesting, but then we may decide to demonstrate that differently on this diagram by making perhaps a smaller line rather than a very thick line. But that is what we're working towards, and that is the picture I would love to have in, I don't know, 6 months' time or so. And so to do that, I really invite you to complete the form. It is open. It is created on Google, but you don't need a Google account to sign in, which I've literally just tested, so hopefully this works. I've made it easier by putting a QR code on the site, and you can also click on the link once this presentation is shared. And otherwise, please feel free to email me and contact me, if you have any questions about the work that we've done, but also if you are having any trouble with the form and would like to get involved in the work further. Thank you very much.
Wow, that was an impressive and impactful piece of work. Unfortunately, the speaker is not here in present, so you would have to probably email her if you have questions. For now, can we move on to the next presentation? Thank you.
I was going to mention, can you maybe broadcast that link so that everyone here can get that sign, and we can, at least the people present can answer.
How do you suggest we should broadcast
I
this?
don't know, by just taking that slide and sending to a group or a WhatsApp group, or I don't know exactly how to do it, but it's a good opportunity to harvest I don't say large,
Yes.
but a number of people to answer.
I do my best.
Yeah, thank you.
Yeah, can we please have the next presentation?
It's there. It's by Luis Fernandez. You can
Is this a recording?
Yes, it's a recording.
Are we having?
Do you have the recording on the medical equipment management status in the private healthcare sector in Mexico? Sorry? Oh, okay, okay. Sorry, I wasn't here for the last session. Okay.
Can we play the video of Luis Fernandez, please, the one you uploaded a while ago? Thank you. No, 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 it was not this one. This is another video. Luis Fernandez. You just upload it on the screen. It's a video. You just have this. Okay, let's go to the next. There's, Which is the next?
The next one, case study, improving Pakistan's health system. Is the author here? Or is this just a recording also?
This is a presentation with an audio.
Okay. Okay, can you please play the video? Thank you.
Hello, my name is Luis Fernandez. Glad to meet you, and I'm here to present our work entitled Leveraging Medical Equipment Data from CMMS Systems for Informed Procurement and Budget Planning in Hospitals. This work seeks to exploit the current capabilities of a tool that we developed that is called Think CMMS, which we used as a second step for understanding how a big hospital group here in Mexico procures equipment and how they use the data related to their medical equipment operations and also all the events that go on throughout the life cycle of each equipment piece in order for us to understand how can we help the hospitals procure more technology in a safer and more reliable way. So I appreciate your time. In this project, 3 people were involved. Luis Ricardo Guerra, who is a software engineer and our CTO. He was responsible for the complete management of our 4 tools. So we have 2 tools for hospitals and 2 tools for medical equipment service providers. So his role was mainly on assuring that everything that the product owner required for this project was delivered, and that with this tool we could also evaluate the scope of this given project. Luis Antonio Gonzalez was a software engineer and also an accountant and our current CFO at the company, was responsible for managing everything related to budgeting and also to understand how the financial process and budgeting went on in these hospitals, and also to help us better understand how these negotiations between providers and users could work in a better way. He was also responsible for developing the financial model behind the financial prognosis that we did, in order for us to understand as well what was going to be the procurement logistics for the hospital. So if CMH wanted to buy, for example, 200 monitors in the following year, he was responsible to understand how the hospitals executed their budgets in order for us to propose a schedule for procuring these technologies. And yours truly, Luis Eduardo Fernandez, I'm a clinical engineer and also the CEO at the company. My role was mainly focused on understanding key processes for HTM and HTA in order for us to interview these hospitals and also survey them in a bigger sense to understand their practices regarding technology management and assessment. With this information, what I proposed was a analysis model that was later executed by our tool that gave us indicators on which technologies should be replaced, why should they be replaced, and also understand if the hospitals were aware of these situations. So the description of the project is that Consorcio Mexicano de Hospitales, or the Mexican Hospital Consortium, is the biggest healthcare system in Mexico. They are a private sector, and also they have over 50 hospitals affiliated. As you can see, Mexico is a large country, and we have hospitals around all of the country, from north to south, basically. And we work with 50 plus leader hospitals that have been not only invited, but screened and selected by Consorcio Mexicano de Hospitales in order for them to basically get together, create projects that help all of the hospitals and also provide much value of this. So what we did is first we created an analysis of what was going on in each of these hospitals, which also was a complementary analysis given one of the studies that we provided in this event as well. So
sorry, the video does not match the presentation, so I'm asking our technical staff to stop that and we go to the next paper. Is that okay? Thank you.
During this technical pause, there is a sheet of paper circulating where we can write our names and email and country, and at the end each one of us will take a picture of that piece of paper, so we all have each other's names and emails. So you'll see the circulating sheet of paper. Actually, Mary was kind enough to give us a blank page for that, because we don't use paper anymore. I don't have it yet. Thank you.
So have you got the next presentation? Can you please play that?
Has a record. You see? It's not loading. Okay, let's go to the next presentation.
Yeah, then we go to the next one. Is it a recording or is the author here? Oh, okay.
Just name it.
Okay, so the next paper will be Embracing Appropriate Health Technology for Affordable Healthcare by Sudesh. Yeah.
Whatever you want.
Yeah.
So the presentation is getting loaded. My name is Sudesh Sivarasu. I am from the University of Cape Town, South Africa. I run a research center and I'm the research chair for biomedical engineering and innovation in South Africa. So in today's presentation I'm going to be speaking about how do we make appropriate health technologies and how can we make them sustainable? It's a very critical factor in terms of innovation and sustainability. So let me see if the slides is working. That's me, and I attribute all of the work to my team. So this is a very familiar slide for all of you because you're here, you understand this. 2 out of 3 people globally lack access to appropriate health technologies. And it's not lack of technologies, it's lack of appropriate health technologies. There is a big difference between technologies and appropriate technologies. The contextual relevance of technologies is what is making the technology more appropriate for them to use. For example, the waiting hours, the pointer doesn't work on screen, LED screens, so we need to come out with an innovation that can actually work there. The waiting hours in the hospitals is a major issue. This can be regulated very well with increasing the number of doctors, but that's a denominator that we cannot change because each country has the upper limit of how many doctors they can train per year, so you cannot actually increase your doctor numbers to match the patient numbers. So what you can actually do is increase the access to technologies, and that's the only way we can actually make the doctors more accessible, and technology is an enhancer of accessibility of clinicians. So I want us to focus on these world mapper screens, and I'm sure you're very familiar with these world mapper charts. It basically gives representation per population, per capita population for a given situation. The world mapper basically gives you for all the conditions, but I've chosen 2 critical factors here: access to sanitation and access to water. I want us to have a very close look at how the Southeast Asian countries, Asian and Southeast Asian countries, and the African countries bulge with lack of access to clean water and lack of access to basic sanitation. Why is that a problem? Because this is again a denominator that is going to directly influence how healthcare is being delivered. And if there were 2 medical devices that you can design that is going to make the world a better place in terms of healthcare, it is by providing clean water and clean air, right? Those 2 will solve majority of the problems. But just look into this: 40% of the global population do not have access to clean water. So that's a bigger problem, and the mapper basically gives us that indication on where the problem lies, and the solutions need to be factored around that. So I just want us to think about this in a more careful way and say, can we bring out with innovations that can change the space? Of course, yes, but I also want to highlight the factor that 95% of all the innovations that we make do not actually see the light of the day. So if you're going to be coming out with 100 innovations, 95% of that innovation do not see the light of the day. So what's even interesting is, how many of you here are from academia, from universities? Okay, including me. Okay. The numbers are even more interesting for innovations coming from academia. 97% of innovations coming from academia do not see the light of the day. Right? Because our priorities are slightly different. We are happy with getting a paper in Nature compared to having an impact. Of course, a lot of us do actual impactful work. So I want to briefly touch on some of the work that we do and then go back to why I'm speaking about the sustainable innovations. So some of these are innovations that have come out of my center. You'll see plenty of innovations from left to right: a portable oxygen concentrator to a portable cervical cancer screening device, a laxity measurement device, add on to a very popular Satch foot, automated systems for inhalers. These are innovations that we made from unmet clinical needs. We also worked extensively on during COVID and innovations relating to social impact and how, if you're interested in any of these, I'm happy to give you a detailed breakdown on where these innovations are currently and what it's currently doing in its life cycle. And it's also important to look into commercial pursuits, because if you don't factor this, if you don't make industrialization a priority, the technology is very likely to stay in the laboratories. Why is that a big deal? It is a big deal because it is going to feed into that whole regulatory space, it is going to feed into the whole clinical evidence space, and it is going to feed back into job creation. And what's interesting factor is that only 20% of all innovations that are successful are industrialized. I want us to understand the difference between being successful. You can get your device to work in a preclinical environment. That's successful. But only 20% of those successful innovations are industrialized. When you say industrialized, it is basically taking it out of the laboratories into something where you can produce for scale. When you design the tooling and manufacturing methodologies around it, the material selection, the sterilization, the packaging, the certification, only 20% of innovations go through that phase. And I'm sure we are all familiar with the technology readiness levels. Technology readiness levels, for those who are not familiar, was introduced by or was adopted by NASA for military purposes. But let's use one of the lenses. There are many lenses that we can use to see how the innovation progresses, but let's use something that is more standardized as technology readiness level. So what this basically gives you is, when you have an idea, it's TRL 0 or technology readiness level 0. What we do at universities is pretty much between TRL 1 to TRL 3. In TRL 3, where we do concept validation, that's most of what we do in academia. But there is more to it. You have to pass from TRL 1, 2, 3, 4, 5, 6, 7, 8, 9 before you can get your medical technology to actually see the patient or the doctor who's going to be using this. For you to go through this entire phase, the regulatory and compliance factors comes in TRL 7 and 9. So for us to go through that entire phase, it's either we're not planning to do it or we do not have the infrastructure to do it. One of the other contributes to this factor. So this is a classical example that I use in my medical device lectures. Several steps that are involved in designing a medical device. Step 1, what do you do? Step 2, what do you do? How do you go from one phase to another? But there are 100 other steps that are in between these individual stages that are mentioned here. Why I'm saying that it's important for us to understand this is, if you do not factor all of this in your innovation space, it's very likely that your innovation is going to be failing. As I kept mentioning, universities are, as academia, academic research institutions and science councils, we are very good in TRL 1 to 3. But industry is very good in TRL 8 and 9. There is a bigger gap between TRL 3 to TRL 7, 8, 9. And that is what we classically call it as the valley of death, right? The valley of death is where the innovation fails and it actually succumbs, because that bridging is not happening. But if you really are intentional about your innovation to make it sustainable, you need to think about this entire value chain. You need to think about how you're going to be crossing each of these TRL levels from TRL 3, 4, 5, 6, 7 to 8, 9. How are you going to cross that? And we all know the chasm, right? The valley of death chasm. It's a very, very interesting phenomenon where the technology develops and then it fails and then it takes again. But we have a slightly different philosophy around this, that we say that there are multiple valleys of death. It's not really one valley of death. There are multiple valleys of death. There is a valley of death when you are proving a concept. There is a valley of death when you are going into tooling manufacturing. There is a valley of death when you are going into compliance, into regulatory post-market survey. So there are multiple valleys of death, and we need to understand that each of these stages in your multiple valleys of death requires different interventions. You need funding, you need to have contracts in place, you need to have IP sorted out, intellectual property sorted out. I was doing a basic cost analysis last month, And something that came up which was very striking was that a low-risk medical device, for a low-risk medical device to pass through this entire phase that we are talking about and to cross the multiple valleys of death, the minimum time period that is required is 5 years, and the minimum investment that is required is about $5.5 million. A minimum of 5 years and a $5.5 million. The median of the time period that is expected is about 11 to 12 years. 11 to 12 years of time period, and the cost factor related to that is about $22 million. That is an average time that is taken from minimum to a median time for innovations to go through. For your innovations to be sustainable, what makes it more investable, that volume of money, is the appropriate IP. And we need to factor that in, and we need to put all regulations in place to ensure that we break those barriers that prevent us from entering into the market. I want to bring your attention to the book that we recently published with respect to medical device innovation in Africa, and it will be quite helpful to see how we have used some of these innovation strategies and the life cycle management approach. Again, the emphasis I want to emphasize the fact that innovation is not done in isolation. Innovation has to be done in a bigger factor. You need to understand the entire life cycle, and you need to make sure that you consider the multiple valleys of death that your innovation is likely to pass through. And if you are really wanting to sustain your innovation and make the innovation appropriate, you need to factor all of these things into account. I've specifically not made it relating to a technology, because I've listed several technologies there. If you're interested, I can talk you through to the life journey of each of these technologies. But at a systems level, if you're looking at innovation to be sustainable, you need to think beyond your own comfort zone, which is where the multiple stakeholder engagement and multiple stakeholder involvement in your innovation comes into play. With that, I would like to thank you, and I'm not sure if I'm allowed to take questions. I'll hand it over back.
Thank you for an interesting presentation. I think we probably have time to take 1 or 2 questions.
Questions?
Do you think it's that expensive to have innovation to the market? I have here it's one order of magnitude less, probably, for small innovation, don't you think?
Absolutely. So you can differentiate this in terms of the lower risk medical devices. Generally, especially the Class A, Class B medical devices, can take much lower time to lower expenditure to go to the market. The interesting challenge again comes in is that when we are doing small batch manufacturing, there is not large investments that is required for small batch manufacturing. But the problem comes in when you move from hundreds of units to thousands of units. That's the real chasm, that's the industrialization chasm. So we need to break that. For us to go into that thousands of units space from hundreds of units, and in a country like India, we need to already think in terms of millions of units. The tooling and manufacturing, the tool and die making for thousands of units, basically that's going to be a 500,000 plus or minus cost. So from a small batch to a medium batch or a large batch, that's where the real costing comes into play.
Let's meet after, but
Thank you.
Thank you, Professor Shudesh.
One question.
Yeah.
So as you were mentioning the valleys of death, so in startups, while the course of development, so the pre-validation and the validation, that is where a lot of funding is required for the testings and commercialization and etc. And investors only will look at a product that is already validated. How in institutes or academic institutes, how is this supported? How do startups get the support?
So it's a $1 million question, because the reason why I'm saying that is any time we say go and pitch a solution, I have a fantastic solution, I have an IP on this, and I want to take this to the next phase into the marketplace. The first question that they ask is there clinical efficacy? Is there proven clinical efficacy? And for us, to prove the clinical efficacy, we have to go through these phases to get it certified, to have the compliance, to have the clinical trials. We need to go through that. And it's a chicken and egg problem, because unless we have the investment, you cannot go into protection to go into clinical trials. Even, for example, if you're going for clinical trials, you need to have a hefty insurance to make sure that if something wrong happens, you're still covered. For example, one of our high-risk medical devices went into first-in-human trials, and the biggest cost was insurance for us, to have a third-party insurance, to make sure that we know that the medical device is safe. But that's not sufficient for us to pay the hefty bills of insurance, to have, and we will know the outcomes of the first-in-human trials in only 6 months, and we are still waiting on that. So it's a chicken and egg problem. So that's an industrialization gap. In the medtech sector specific industrialization plans, we need to ensure that we have investment potentials that is going to take that. One avenue that we have always used to our advantage, but which I will suggest your teams can also consider, is the possibility of using approved multinational IP, a granted patent from proven examining countries, will add a lot more value. So if your investment requirement is about $1 million or a couple of $1 million, what is there for the investors to invest into? An appropriate IP will be one such thing that will help us navigate this challenge. But it changes from place to place and scenarios to scenarios. But that's a great question. Thank you. Chair.
Thank you. Let's move on to the next paper. It will is on accelerating the adoption of new technology, the role of the clinical engineer, by Daniel Clark, and this will be a recording.
Hello, it's great to be here with you today, albeit remotely, and have the chance to say a few words about how clinical engineers can help accelerate the adoption of new technology into healthcare. So I'd like to start by thanking the conference organisers for giving me this opportunity. Innovation in healthcare technology is very often driven by small companies. However, these small companies although they have that flair and imagination to develop wonderful new innovative technology, by their very nature, they tend not to have the experience and expertise to support the adoption of that technology into healthcare, to facilitate its deployment and use in hospitals, or to provide hospital managers and service buyers with convincing evidence to actually go out and buy their new technology. For example then, a small company does not always have the capacity and capability on regulatory matters. It might not have the experience and knowledge on how healthcare providers test and evaluate new technology. Or it might not know how healthcare providers actually go about buying new technology, or an understanding of the wider clinical pathways and systems that technology might be used in. This results in the fact that many brilliant new ideas for technology never deliver their promise to patients because the companies lack the experience and skills necessary to get them adopted. Clinical engineers, however, very often do have these skills and experiences. Working in a healthcare technology management, we're experts in local regulatory systems for medical devices. Often embedded within healthcare providers, we have a wide understanding of the testing and evaluation of new technologies. We work on behalf of healthcare providers, so we have experience in the purchase of medical devices and medical equipment and its subsequent commissioning, deployment and use. And we understand the local hospital environments, the clinical environments, not just in our own areas, but the wider picture on where technology might be used in healthcare applications. So the question for us, as clinical engineers, is how can we accelerate the adoption of new technologies by supporting companies? How can we help these small companies get their ideas adopted? Recognizing then both the need to support small healthcare technology companies and the resources and capabilities that we as clinical engineering teams possess, we established in Nottingham in the UK a unique service dedicated to providing adoption services to small companies. This we called the Centre for Healthcare Equipment and Technology Adoption, or better known as CHEETA. Cheetah was established almost 10 years ago now. It's based in a large teaching hospital in the UK, and it draws on the skills and experiences of us clinical engineering professionals to provide adoption support services to medical device companies. And this presentation then will explore the background and rationale of this service, how it came to be developed, and give an insight into the role that clinical engineers can play to support medical technology industry, companies, and ultimately to accelerate the adoption of new technologies for the benefit of patients. A number of years ago then, I realised that there was a lot of really great new technologies being brought into our hospitals. Clever technology that really met a patient need, and clinical teams who really wanted to use that technology. But the equipment was not always acceptable to be used in our hospitals. Maybe it wasn't manufactured to the correct standards, or it didn't have the right supporting evidence that it actually worked, or it was expensive and the economic case was hard to see or justify, or for a number of other reasons it was hard for our hospitals to adopt this new technology and put the equipment into use. Now, because we're a big clinical engineering department with a lot of experience and expertise, we started trying to help these companies bringing in the new technology, telling them how to manufacture it and make it regulatory compliant, or helping them get the evidence to support its use, or to demonstrate the economic case. But there were two problems for me in doing this. Firstly, we were giving away all this valuable expertise and experience for free, and that didn't seem quite right. And secondly, because we were doing this on top of our usual jobs, we didn't always have the time to do it properly, and so we offered a poor service. So I decided to set up a small team that would be able to coordinate this sort of support for companies and to do it at a charge, a financial charge, so that we could afford to do it properly. And the result was Cheetah, a service based in clinical engineering that draws upon the expertise and experience of our teams, and also being inside the hospital, we had the credibility and the perspective of what healthcare system really wants from new technology. And we found that companies were quite prepared to pay a reasonable fee to benefit from our advice and this support. So there are a lot of challenges that you face if you're an innovator of new technology, trying to get your ideas, your new products accepted by the health service and adopted into use. And we see ourselves at Cheetah as being the guide, if you will, who can escort the company through the maze of challenges, from regulatory and compliance issues to user needs to training in the health service to health economics to business cases to NHS procurement systems. Anything, in fact, to help them navigate their way to success. So we support innovators from industry, from academia, and we guide them through the various challenges they need to overcome to help them get their new technology adopted into the NHS. Over the years, we've developed a wide range of services, depending on what the innovator, what the company needs. We can do device value propositions, we do health economic modelling, we help engage with government programmes like NICE, we do regulatory compliance support, clinical investigations, health technology assessment, we can do literature searching and evidence appraisal, we have human factors available and simulation centres, we can engage with key opinion leaders in clinical environments, we do medical devices training for NHS adoption, and we can identify potential new clinical applications or patient opportunities. Now, not all companies need all of these services, of course, but many need some. What we in Cheetah really understand, and how we can really help companies, is explaining what the NHS actually wants from a manufacturer. And it comes down to actually only 4 simple things. Firstly, their new product needs to be regulatory compliant. So of course in the UK that means it needs to be either CE marked or now the new UKCA mark. And we've got regulatory experts in clinical engineering in Cheetah who can help with that. They also need to see evidence that the device actually works. course the NHS wants to know the technology actually works, but we no longer just accept what it says in the glossy brochures or the sales pitches from reps. We expect to see evidence from investigations or clinical trials or audit data. And again, small companies don't know how to go about getting this evidence, but we in Cheetah do and can help them with that. Again, the NHS needs to know if it's going to get new technology, how that device is going to be incorporated into its existing patient pathways, the way it currently looks after patients. So when you deploy new technology into a healthcare system, you often need to understand how it will affect that system. Will it be disruptive? Will it change the way staff work? Will it fit into the existing clinical pathways? And again, we understand in Cheetah how to do that. And then finally, there's the health economic assessment side of things. The NHS will not be unique in facing difficult financial environment at the moment. So we need to see the health economic case for new technologies. MedTech specific health economics is quite difficult to do and quite hard to find. But again, Cheetah has its own health economics, and we've developed our own set of tools to help companies with this. Now, okay, I appreciate that everything I've said so far is a little bit theoretical, but over the past 8, 9, 10 years, Cheetah has supported something like 100 companies progress their medical device products along the adoption pathway. So I thought it might be helpful just to look at 2 or 3 examples that we've done. So this first example then is called Silhouette, and it's for patients with diabetic foot ulcers who are normally treated at major regional specialist centres in the UK, and they have to travel into these larger hospital sites to see the specialist team who then make decisions about their treatment. Silhouette is a high-resolution camera system with associated software that enables patients to attend local centres where images are taken and can be assessed by the regional specialist team. This means that the patient no longer has to travel, and it can speed up the treatment decisions. But this is a big change to the standard way of looking after patients in the NHS, keeping them local, being seen by non-experts, and with the support of the regional experts coming in remotely. Is this as effective for our patients? Do they get as good results? And moreover, the equipment is quite expensive and it needs to be established in lots of smaller units. So, is this new service using Silhouette effective clinically, and does it cost more or less than the traditional way of working? Cheetah was brought in to review this new way of working and produce a health economic analysis that's actually supported the adoption of this new service. Our second example then is from a major research project looking at a novel wound care technology using fibre optic sensors actually inside the wound dressing to monitor how the wound was progressing. The science for this project was very compelling and the technology looked really, really useful. But if it was successful after the project, would the cost of introducing these smart wound dressings be affordable in the NHS? So Cheetah was brought in to support the research programme, first by undertaking a value proposition that enabled the project to understand what the cost of the final device would have to be to make it affordable for the NHS. Cheetah also supported the project with pre-compliance testing to make sure that any final product that came out of the project would be acceptable to the NHS. And finally, Cheetah helped the project establish and deliver a clinical trial utilising our experienced clinical trials manager and our proven track record and system of running medical device trials. And our final example for today is called Peristeen, and it just shows the scope of the activity that Cheetah get involved with, because this one was a project that supported a large multinational company. This company had just launched, in 2003 actually, had launched a product called Peristeen, which was a transanal irrigation product designed to help people with neurospinal trauma or disease to enable them to affect normal bowel evacuation, to go to the toilet, if you like, normally. Despite being launched in 2003 and despite having a lot of good clinical evidence, the product was seeing very poor adoption rates in the UK. So CETA was brought in, and we suggested taking the product to NICE for evaluation. Now in the UK, NICE, which is the National Institute for Health and Care Excellence, is set up to evaluate drugs and technology, but it can evaluate new technology, and it makes recommendations to the whole NHS about adoption. So CETA came in and supported the company with its evidence and the way to submit that evidence to NICE, and it enabled the company to get a positive recommendation from NICE that said the NHS should adopt their product. So we've seen then that clinical engineering teams have huge experience and expertise that can help companies, particularly smaller companies, to get their new technology adopted. Clinical engineers are well placed, being inside the hospital and therefore able to appreciate the healthcare perspective, but also being technical and able to understand the new technology challenges and requirements. By pulling in experience from clinical engineering departments and from clinical teams and from specialists at HTA, CETA has created a portfolio of services to support medical technology products progress along the adoption pathway. In doing so, we have helped over 100 products in the last 10 years and have accelerated the adoption of many exciting new technologies into healthcare. Many thanks for your time today and for listening to this presentation. Thank you.
Sounds like a very profitable way of operation. Since we cannot talk to the presenter, I actually would like to direct a question to Professor Sudesh. Do you think something like this would help in your earlier presentation on innovation?
It definitely will, and it kind of, again, in medtech space, the additional infrastructure is what adds up a lot of cost for simple things like QMS maintenance, like having ISO 13485, 9001 or 14971 certifications. That's a big cost for every startup to have. So if a company like this or a setup like this provides those kind of infrastructural support, and also going into small batch manufacturing, as I kept saying, if this can be done in a certified facility which has QMS, quality management systems, very well established quality management systems, as well as medically approved processes, and if they are GMP, good manufacturing practice certified, and GCP certified as people involved in it, then it actually bypasses many of the hurdles that we will be encountering as medical device technology innovators. Thank you.
So, is there anybody in the audience who would like to share any further insights in areas like this? Any further insights related to this?
So I'm happy to share further insights, especially there is a need for establishing hubs like these, like to avoid the overhead costs that goes on to innovators and young startups. And as a medical technology younger startup, the cost relating to access to clinical trials, the cost relating to managing technical files, the cost relating to medical certified production facilities, if that can be covered by like a facility like AMTZ or an equivalent of that, it would actually save our lives significantly, the amount of time and effort that we spent on fundraising for developing these things. And very important thing that we spend a lot of time and effort is certified auditors who can do the technical documentation, and that's a big challenge, and that's something that a facility like this can actually bypass all the efforts that we put into it. So a hub which offers these multi-sectoral support for medical device practitioners would be really helpful.
Thank you. All right, I think we should move to our next presenter and paper. This will be on the impact of NEST 360 program on newborn technology management by Millicent. Do you want to present from here, or you want to go over there? Up to you, up to you.
Good afternoon, everyone. Good afternoon. Is it morning or afternoon? Afternoon. Okay. Morning and afternoon. No, I think it's afternoon for all of us today. So yes, thank you so much. Millicent from Nest 360. I'm going to take us through the impact of Nest 360 program on newborn technology management. What we've been able to do to ensure that we impact the management of medical devices and the newborn units. So just in case you're wondering what is this Nest 360, so Nest 360 is Newborn Essential Solutions and Technology. It's an alliance of many organizations, 17 of them, 13 of which are in Africa, and they all came together to reduce neonatal mortality in Africa, going by SDG 3.2, which is for newborn survival, and ENAP Target 4, which is also talking about newborn survival. And so currently Nest 360 is in 4 countries, Malawi, Tanzania, Kenya, and Nigeria. We are planning to move into Ghana and Ethiopia in the next coming year. And so we are in 67 hospitals in these 4 countries, and we've been able to do quite a bit. So how do we ensure that we reduce the preventable newborn mortality? So we deliver and sustain innovation, something that we are going to look at briefly. We also develop a very robust education ecosystem for both biomedical and clinicians, and we also implement using the evidence-based. If you look at our data system, that is something that we do. Now, these are some of the impactful initiatives that Nest 360 has been able to do, and we're going to look at this in totality. We're looking at improved HTM processes for procurement all the way to disposal, that is in African countries where we are in, develop PPM schedule, and among all that, you're going to look at them in totality. Now, at the beginning of the slide, I asked, how does Nest 360 ensure that we reduce neonatal mortality through neotech management? That is newborn technology management. So we deliver and sustain innovation. One thing that Nest 360 together with UNICEF did at the beginning was to come up with something called TPP, that is Target Product Profile. And we developed this to give minimum, rather basic specifications for the devices that are used in newborn unit. And then we made this to be open access to anybody else who wants to set up a newborn unit to be able to use. And this was done with, together with experts from different organizations. And so currently, if you get to our website, you'll be able to find the minimum technical specifications for all the list of essential newborn devices that we actually engage in. And so from this TPP, we were able to identify 23 technologies. Of course, we are not able to supply everything in the newborn unit, but we look at the bare minimum, and we looked at the very hard to reach areas whereby newborn death is so high, just probably because of lack of pulse oximeter. They don't know the level of, they cannot measure the SpO2 in the body of the baby. Or probably just because of lack of oxygen. Something as simple as getting oxygen concentrator nowadays is very affordable, but they can't afford that. And a very simple thing like probably suction unit, decongestion of the chest. So there's quite a number of things that we looked at, and we narrowed down to 23 technologies. And out of that, we've been able to supply 3,381 devices across all those 4 countries. And how have we been able to do that? We do this together with the Ministry of Health, together with the facility management, and together with the biomeds included. So we start from all the way from procurement, we train the biomeds, and then we ensure that we maintain, we decommission when that time comes, and we ensure safe disposal. We look at that briefly because we may not go into nitty-gritty details due to time. But that's basically how we've been able to improve the HTM process. And we are working with different ministries of health to ensure that they follow the right procedure when it comes to procurement, training the biomeds, and even maintaining these devices, because most of the time you realize that whenever a device has been supplied, especially in African countries, we have various NGOs and even various companies that supply devices. They supply and that is the end of the story. Nobody follows up to see are they maintained. Nobody follows up to see are the biomass who are taking care of the devices trained. What about the clinicians who are the users? So the device is brought in African country and they are left lying idle. At the end of the day, they form something we call it graveyard of medical device or a junkyard. And that's a big problem again when it comes to environment. So that is something that we are really trying as Nest 360 to ensure that we educate and we create awareness on ensuring that improved HTM process is followed across all the 4 countries. We've also really worked on improved collaboration between the biomeds and the clinicians. Initially, the biomeds and the clinicians in African countries, the biomeds, they sit somewhere in a corner and they don't know, somehow they don't understand what they're supposed to be doing. And if they do, then they get confused probably with the carpenters or maybe plumbers and you know, they're being allocated any duty. So what we've done as Nest 360 is to improve this collaboration. How do we do this? We train these people together. We call them for trainings together. For clinical use, biomeds are trained. Apart from the technical use whereby you need to open the device like the way this lady is doing, so then that will be biomedical training only. But we call these people together and train them together to increase that collaboration. So even as you can see from here, you'll be able to see this a biomed number. For me, this is a very small thing, but when I went to this facility and I found a biomed number on a nurse's notice board, I was rejoicing. I was so happy because that shows me they've already identified and noticed the importance of having a biomed in a facility, and they can easily reach out to this particular biomed to come and sort them out whenever they have an issue with the medical devices. So that collaboration right now is great in various countries where we operate in, and we have seen a lot of improvement when it comes to that. Secondly, one thing that Nest 360 has been able to do, which is not done by I would say 90% or 95% of the people who give devices, is provision of the toolboxes for the biomeds to use. Like any doctor, when a doctor gets into a hospital, the first thing they'll be given is stethoscope. And you see them walking with stethoscopes around their necks, all over. And people know that they require this. But what happens to a biomed when they're employed? Nobody remembers they need toolboxes. So they get employed or they're given devices and they sit. No toolbox, you are called to come and repair a device, bare hand. You can't do a thing. The next thing, you are redundant. You can't do anything and you are packed together with the people who are not delivering in the facility. So we have been able to supply all the facilities. The 67 facilities are all having these toolboxes to be able to maintain the devices in terms of planned preventive maintenance and even corrective maintenance. And apart from this, we've also given them some quality analyzers like the oxygen quality analyzer to be able to check the quality of oxygen delivered to the patients. So then with this, the biomeds, the clinical engineers are really, really motivated to work because they have the tools of work. And so with that, we have seen improved planned preventive maintenance. They're able to plan, they're able to do the corrective maintenance at the facility level without depending on us because they have the right tools. We've also, I think a lot has been said about tele in the morning. And also we have the AI thing that is coming up right now is the in thing. So as Nest 360, we are also also moving with the speed the world is moving at. And so we've come up with this device monitoring system that is, it's a very simple one. It's just as simple showing me on or off. It will not show me many things, but I just want to know whether the device has been on or off. So when I see the device has been off for a very long time in a given facility, then I'll pick a call and call this biomeds. I've been seeing this particular CPAP unit off for the last 1 week or 2 weeks, and I know you have very high influx of patients. What's going on with this CPAP? Does it mean it is broken down? Is it that it's no longer in use? What happened? Then from there, we'll be able to see exactly whether the device is broken down, the device has been misplaced, because that happens a lot in the facility, or the device is just somehow locked
in a box because the head of the unit is away on leave. So you're able to sort out some of the operational issues that happen and you get your devices back to work. So this is called Hadley monitoring system. It has been able to help us to track our uptime of the devices, and we're able to see quite a lot of improvement in the equipment utilization. Because one thing you don't want to see and know is that you've invested a lot of money in buying the devices, you take them to a facility, then they are not utilized. It is really a demoralizing factor when it comes to a donor or a funder that your devices are not helping what they're supposed to do, especially for the newborn babies. Now, we have also improved inventory management system. I know biomeds or clinical engineers maintain the inventory of devices they have in the facility. But one thing that is not clear is whether they maintain the accessories, the consumables, and the spare parts that they require. So this is something that we've introduced to these particular 67 facilities where we are, in that in as much as they have the inventory of medical equipment, we also need to know the inventory of accessories. Like this is just a sample inventory of the accessories of some of the devices that we supply. And as you can see, it's a big challenge because a hospital can be having like 7 brands of oxygen concentrators. And you really have to maintain all the accessories of each and every brand. It's been really a challenge, but it's a journey that we actually continue with, that we ensure that ACS inventory is maintained as the same way as you maintain the inventory of medical devices. The implementation of planned preventive maintenance, I talked about evidence-based care. We monitor this to be able to see how are the countries performing the planned preventive maintenance. And we have a data system called NestIT data or NestIT data, where this is logged in and we're able to see what is the preventive maintenance like. We'll see some are so blue, some are like reducing, some are increasing, and they have different challenges, starting all the way from lack of enough understaffing, lack of probably, spare parts in some. And with this, we monitor all the devices in the newborn unit, not only Nest devices. So at times you'll find it low because other vendors have not been able to supply what is required. But we are able to know at least what is the trend like, and we're able to support where we can. And we've also developed, if you go to Nest 360 website, and I would urge all of us to visit, even as I conclude, I would urge all of us to visit the Nest 360 website to see the number of the materials that we've been able to develop in order to build capacity for BME and even clinicians. All those devices, the 23 technologies that you saw up there, they have materials. We call them the job aids and the job modules. So the modules have the comprehensive end-to-end, how the device is being used, what are the troubleshooting guides, what are the ifs, the device is behaving A, B, C, D, what do you do? So the biomed, when they pick the job aid for oxygen concentrator, even without calling Millicent or any Nest biomed in any country, they're able to get a guideline and they're able to do the maintenance and repair of these particular devices. So these are free access in our website. You can access all these materials across our websites to be able to support the biomeds to learn on how to use, how to maintain these particular devices. I was forgetting about a very important fact here, mentorship. That is mentoring these devices. We do hands-on mentorship. Yes, I know we also have webinars, but we are so much on the ground to ensure that the actual machines are maintained in the right way. We open the devices together with them because we are not able to take them all to the factory where the devices have been developed. But we open the devices together with them. We learn each and every component into detail so that by the time I'm leaving a facility or the Nest Biomed is leaving a facility, they are all aware of what exactly they are supposed to do. And so that is one of the trainings in Tanzania, and this is in Nigeria. We're just looking at how do we, maintain these devices without ensuring this downtime of the devices. And so thank you so much. In case you have any question, that's my email address. You can always reach me. Thank you so much. Merci.
Thank you so much, Millicent. Any quick question from the audience?
Hi, Millicent. Great job. I have a question. How did you make it? How did you convince the Minister of Health to invest in your project?
Thank you so much. So it's not been a very easy journey. I wouldn't say it was a walk in the path, and it's a journey that we are still on. So what we have done is that there are different ways the health is managed across all these countries. You will find there are those ones that are having centralized health system, there are those ones that are having decentralized health system. So we've approached them in very different capacities. And so for us, like in Tanzania, it was very easy because the president of Tanzania has the centralized health system. Everything is done centrally. Unlike Nigeria, where you really have to go through the federal government, there's quite a lot that needs to be done. So for us, we give proposals, we have several meetings with them. Of course, some are being implemented, some are not being implemented. And so because these are free services that we are giving to them, it was very easy to penetrate because they really want our services. And first, what we did and presented to them is something called HFA. Health Facility Assessment. We're able to assess facilities that we really wanted to go into and came up with a very comprehensive and robust evidence-based data that was showing the mortalities of newborn and how we really needed to reduce this mortality. So with that kind of a data, when we presented it to different ministries of health, it was something that was touching, that look, this is actually happening in Africa. It's easier said when WHO says 80% of neonatal deaths are in Africa, until you say it is in my country that I'm getting this number of deaths. So there's something that needs to be done. So we really worked on data, really comprehensive HFA that we did that was able to inform us of where exactly do we need to dive deep into and what exactly do we need and how do we approach that. I don't know whether I answer your question. But yes, it's still a long journey because right now what we're really working on is ensuring that we integrate with the government system so that they can actually also pick up from where we are. We are not able to get into all the facilities in all the 67 countries. And of course, the other facilities, they're also suffering and they need our support. So we are trying to get the government to buy into this idea and, you know, start purchasing this particular basic neonatal equipment to be able to care for the babies. And some of the countries have actually incorporated the essential list of devices, and they put aside budget, like I know Tanzania did that, Kenya has done that, Nigeria still somewhere there, in Malawi. So yeah, we are there, still struggling, but you know we'll reach there like comprehensively. Yeah.
Thank you very much. In view of the time, let's go on to our final presentation, Innovative Diagnostic and Therapeutic Technologies for the Protection of the Hip Joints in Children by Dr. Irina.
Okay, I want to say thank you all organized committee for this brilliant event, for this brilliant challenge for us. And I studied about a result of early hip surveillance and peer-to-peer intervention for reducing disability burden in the children. Introduction. World Health declared the Global Action Plan, Better Health for all people with disabilities in the last decade. Cerebral palsy. Next, please, sorry. Sorry. Better health for all people with disabilities. Cerebral palsy is a predominant case of the childhood onset physical disability globally, impacting an estimated 17 million individuals across the world. Childhood hip disorders and cerebral palsy account for the largest share among all disabilities in children with motor impairment. Various hip disorders can lead to adverse outcomes, including degenerative joint disease, hip displacement, significantly shortened limbs, scoliosis, severe disability, and loss of basic mobility. According to numerous literature sources, damage to the growth zone of the hip joint bones is particularly critical, especially within the first 5 years. During this period, the bone matrix is formed, their congruence is established for life, and fundamental motor skills, verticalization abilities, and gait patterns are developed. Children can have developed osteonecrosis as a consequence of severe motor impairments, yes, but often due to the complications arising from incorrect treatment protocols for conditions such as cerebral palsy and other motor disorders. Effect of peer-to-peer treatment intervention on osteonecrosis femoral head. It will know about the important role of the mediators as growth factors for neoangiogenesis, cell growth, osteogenesis, and survival of growth plates of impairment trabecular bone, for inhibiting inflammatory reaction in necrotic lesion and preventive apoptosis. According to the scientific research and worldwide experiments, there are no generally accepted protocol and clinical trials about PRP non-operative recovery of the femoral epiphysis in the children with Calvi-Perthes disease or osteonecrosis femoral head. Hip displacement as common outcome in children with cerebral palsy. Abnormalities of the turn, posture, and movement are associated with secondary musculoskeletal complications, such as joint contractures, hip dislocation, and reduced bone mineral density, leading to fractures, pain, and progressive disability. Hip displacement is the second most commonly musculoskeletal deformity in the children with cerebral palsy. Its last decade, major discoveries have been made in the early diagnosis, prevention, and treatment of CP. You can see a lot of hip diagnostic and monitoring tools. In the last decade, in high-income countries, the implementation of CCP strategy has led to a 70% reduction in the incidence of cerebral palsy and decrease in the severity of the motor impairment. Early verticalizations and postural management. The issue of the early verticalization and postural management method for protection of femoral head bones in the various pathological conditions of the hip joint remains open and debatable. A postural management program is an integral part of the life cycle approach that incorporates all activities and interaction affecting individuals' posture and overall function. Standing frames are utilized for the children with cerebral palsy to enhance body structure, function, reducing the risk of the hip subluxation, improving blood and bowel function, enhancing activity, motor skills, and increase participation, social interaction with peers, and education. Kazakhstan situation. As of 2022, there are 98,000 children with disabilities in Kazakhstan. Disease of the nervous system account for 29%. In Almaty, the biggest city in Kazakhstan, there are 5,500 people with disabilities, and among them 1,500 children with cerebral palsy. The analysis of the scientific source regarding hip programs such as hip sonography, CPUP, and early prevention of hip dislocation or osteonecrosis revealed that there is limited data available with only a few reports from Kazakhstan. The country lacks a standardization institutionalized protocol that incorporate modern tools for hip surveillance. The existing hip surveillance guidelines are outdated and highlighting the necessity of developing a new framework for national hip surveillance guidelines. Study goals to minimize childhood disability and reduce the need for hip surgery through innovative hip surveillance guidelines. In this research, we analyzed available techniques of diagnostic and therapeutic treatment of the children's hip joint in Kazakhstan, evaluate the first result of innovative orthopedic interventions. It's about our approach, it's about our new approach, combination of the method such as postural management and PRP interventions for the protection of the hip joint in children with osteonecrosis. Assess the first result of implementation of the hip surveillance and postural management intervention for the protection of the hip joint in the children with motor disease. We have a weight limitation. It's first, the COVID-19 pandemic disrupts the initial research schedule and reduces the number of the patients available for observation. And second, due to the insufficient funding for this project, expensive equipment costs were borne by the parents. Limitation. They were challenge related to understanding and accepting the complex treatment protocol, both in the hospital setting and in the home. You can see the study design and patient selection. You can see the 5 groups, and the group number 1, 2, and 4. It's in gray. It's about retrospective evaluation the date. And first group according to message group. The second group about according ICF World Health Organization. It's a new international classification function. And the fourth groups, it's about the new approach, X-ray examination, X-ray index or migration index. It's about head of femoral bone. And you can see the two groups with in green. It's about our new therapeutic approach. The third group is about therapeutic approach for the treatment cell-based PRP interventions, plasma lifting plus postural management, and we evaluate our result by ICF. And the fourth group, it's about orthopedic hip surveillance and early interventions, and evaluation by ICF outcome. And the third groups, it's about children with osteonecrosis, and the fourth groups, it's about children with CP, cerebral palsy, I mean. We have got results in the in the first group until the age of the 40 months. The ultrasound windows were open in 82% of live birth weight and premature babies along the monitoring of congenital and acquired disease using the sonography message ultrasound center without radiation exposure. It's very, very important for children. Distribution of the children by sonography type of hip joint matter according to graph showed that type C, D, 3, and 4, its very severe type, makes up 5% of the total number of all sonography. What does it mean? It means that these children had a progressive hip displacement, and they need in the early orthopedic intervention in the first year's life. Group number 2, the retrospective evaluations of radiological imaging in children with prostate disease. It's about previous existing standard therapeutic treatment. You can see we used the ICF classification. You can see the domain that we chose for monitoring. It's about structure, function, activity, and other. And you can see the hourglass to improve shape and structure, to improve walking, decrease the pain in the affected leg, to increase the mobility of the joint. And it's pretty bad the development of osteonecrosis continued and worsened, and all these children were referred to the surgery. You can see the two photo. It's about only 2 patients, but it's about after the surgery with a head of metal construction. And you can see the group number 3. It's about our new approach. It's about early intervention for children with prostate disease or osteonecrosis, and you can see our schedule in the 1 second, 3, 5 years. You can see the photo with injections, PRP, and part of the brace device for postural management. And we checked the same domains, and you can see the qualify scales before and after our intervention. Check piece about in the first sentences before and the second sentence after the treatment. And we choose the goals, improve the shape of structure, improve the walking, decrease the pain in the affected leg, increase the mobility of a joint. And the development of osteonecrosis was full stopped and reversed in all the children, and so there was no longer need for surgery, and all this patient could come back to the previous sport activity. You can see the MRI and the most important signs: elongation of the suffering leg femur by the 1 and 1.5 centimeter, and complete restoration of the patient gait were demonstrated in the 24 and 30 months after the onset of the PRP plasma lifting intervention. And group number 4, it's about patient with cerebral palsy, and it's about retrospective estimate. You can see the age disruption of the patient distribution of the patient. And why it's important, because green group, it's about group the children with first 3 years old, and its group has a high potential for the rehab, and this subject for the time in intervention. And the second group in the red color, it's about the older group, and the children are aged from 2 to 14 years old, and this group has already various form of disability, and the assessment by GMFCS. GMFCS is a very important classification about general motor function classification system, and you can see that the children with severe type 3, 4, and 5 types make up 74% of total number of the patient. And with distribution of the patient with cerebral palsy, according to quantity of the pelvis radiography, MRI, and standing scales. The radiology imaging in green and the standing scales in the red color, and retrospective analysis of the 2018 case histories showed that radiography of the hip joint is performed rarely and regularly. In this group of the children, MRI of the hip joint was not conducted, and level of low stability to stand with support was as high as 77%. And retrospective data of available hip X-ray of the 160 patients, it's about existing practice. It's not our approach, it's existing practice, shows that severe complications, severe hip complications, including the severe hip subluxation, dislocation, make up 74%, and there are the questions what influence the femoral bone more, the primary muscle tone impairment or the restriction of the vertical static load. And about the last group, it's group number 5, it's patient with cerebral palsy. They were undertaken for orthopedic hip surveillance and early postural management interventions. And you can see the different type of early interventions according to hip type, okay? And you can see the photo with part of device for postural management. And we chose the domains ICF classification. It's about structure, function, activity. It's more important. And you can see our goals: achieve hip joint protections. It's stop migration, head of family. Reduce spastic adduction, hyperthermia, improve functional endurance, increase lower limb muscle strength, and attention please, eating and drinking. And decrease of the ICF classification scales by 1/3 point across 2 or more domains demonstrates the effectiveness of early hip surveillance and intervention. And you can see that we really improve the function in this domain. And our conclusion. The conclusion of the child's hip is not just about hip, but the basic life activities, skills, and socialization. Our efforts in following the new approach to hip surveillance and timely treatment represent a significant step toward reducing disability in the children with hip problems. This marks a positive stride in our ongoing commitment to improve the well-being of these children. The early hip intervention, including the peer-to-peer cosmological treatment message and postural management, represent a promising approach to prevention of hip surgery. These interventions have shown a potential for enhancing the overall quality of life of these children. While the initial results of our study have demonstrated promising outcomes, it is imperative to emphasize the need for the ongoing research. For this, investigation is required to comprehensively analyze the suggested message and unlock its full potential in addressing these heat disorders. Continuing research is vital to refine, validate, and fully understand the implication of this approach, ultimately contribution to enhance the outcome for this target population. Thank you for your attention.
Thank you for a very interesting presentation, Dr. Irina. In lieu of time, we will not take any question for this. So if you have questions, please ask her directly after the meeting. So this is the end of this session. I understand you want to take a photo or something? No?
With pleasure.
If not, that's fine. It's lunchtime, so you need to go and
I just wanted to add that this work, it's done purely by initiative of Dr. Irina Khizhanova, and unfortunately the bureaucracy which exists, it does not allow to move forward with available yet effective technologies and appropriate, as Dr. Sadesh said, technologies, and that prevents and help reduce the burden of disability, of these grave consequences. So the early start makes the life of these children is really normal, as opposed to like late start when it's already disability, and it gets only worse over the years. Thank you very much.
Test. Okay. Well, welcome, friends. I almost don't need this microphone because I speak very, very loud. I'm delighted to be with you. My name is Elliot Sloan. I'm a dinosaur in this modern age, but perhaps a young dinosaur. And we're going to talk about home care in this session. And it's an uncomfortable field for us. It's uncomfortable because the contained environment of the hospital, which we are most familiar with, it can't be maintained in the home care setting. And so we're going to have to come up with some innovative methodologies to provide safe and effective home care. And I have the pleasure, first of all, I'm with Villanova University in the United States. I'm a professor of health informatics. I teach cybersecurity. I teach mobile health technologies. I also am a co-founder of the PULL Alliance with Dr. Manish Kohli and Tom Judd. I'm also the founder and CEO of the Foundation for Living Wellness and Health. So I have a lot of different roles, and I've worked in the healthcare field for half a century. That's not long, is it? Half a century. And it's been a pleasure and a remarkable journey, and I know folks like Hashem from classes and things we did 40 years ago, so I have the privilege of friendships that go through many, many years and across many, many continents. Which way is, so I'm not advancing. Do you need to, is it turned? There we go. So this is based on work by Dr. Tony Easty and Dr. Bill Gentles, and also a young, recent master's degree clinical engineering student, Eric Wong, with BT Consulting in Canada. And it emerged out of the Canadian Standards Association asking for a consulting team to help them understand the gaps in home care technology, regulation, and policy. So Canada, as you know, is a vast continent, vast part of the continent, Pacific, all the way up to the Arctic Circle and further north. So it has many, many, many different environments that they have to support. And I have a lot of colleagues in Canada in many of these different areas, including north of the Arctic Circle, two very good friends, Kevin Taylor and his family have been up there for decades dealing with the harsh realities of an area that is frozen in ice and in darkness for a good part of the year. We have, because of the COVID pandemic, we all experienced home care technologies. Even in the smallest countries, we wound up with oxygen technologies, we wound up with pulse oximetry, we wound up with home care, nurses, aides, various forms of remote patient monitoring. It could be as simple as a text messaging system. How are you feeling? How are you breathing? The UK created a pulse oximetry at home program where they issued patients a small pulse oximeter, and the nurses called them at home to find out how their saturation was and to determine if they were getting sicker and needed to come to hospital. The Canadian Standards Association tasked us with looking at all of the available standards both internationally and in Canada that related to regulatory compliance, related to acquisition of technologies, the deployment of technologies, the life cycle ownership of technologies. And we have a lot of areas that we've talked about, such as these four: appropriate and affordable telecommunication tools, so the pointer's not working, appropriate supply chain resources, but it's still advancing, health technology assessment and management strategies, and the creation and maintenance of a sufficiently safe environment of care. They asked us not to look at telehealth. They had another team working on telehealth, and so telecommunications and supply resources, they also had another group working on. Our goal was to identify critical gaps and requirements for safe and sustainable medical technology in home settings. It was a little broader. They called it home and community settings, community care settings. So that included nursing homes, assisted living homes, elders living in group homes, and the like. Identification of critical HTA and HTM adaptation recommendations to help improve the safety and sustainability of laypersons using medical devices. Remember, it may be grandmother or grandfather who is using these, or a son or a daughter, or a neighbor or just a friend who is helping use those devices. They have no medical or nursing or technical training. So how do we help them? And then a large collection of reference guidelines and practices. And I really worked very, very hard to give us open source documents. So this report is available free as a free PDF from the Canadian Standards Association. And we actually found about 300 different open source documents with HTA recommendations, HTM recommendations, maintenance algorithms and procedures, guidelines from WHO. All of those were intentionally put there for all of you to use in developing your own programs. And it's focused on clinical engineers, health technology managers, health policy advisors, clinicians, and patients. The policymakers are really stymied by home care. They know they have to provide home care. They know that it's less expensive. Ethically, morally, they don't want their mother or grandfather to be harmed by this technology. But the control and management of it is very, very difficult. In the U.S., we're having a lot of discussions and quarrels about it because it's very hard to contain the costs. If everybody has a pulse oximeter, if everybody has an oxygen concentrator, it gets very expensive. If everyone has a hospital bed, it gets very expensive. So how do you maintain them? How do you buy them? When I worked for Medic for 10 years, we were a medical device manufacturer. And I want you to listen carefully. We owned 50,000 infusion pumps. We owned 30,000 pulse oximetry devices. We owned 40,000 ventilators. All of those had embedded batteries, and every year to 2 years we had to replace nearly 100,000 batteries. Just imagine the disposal challenge that we had for that, and the safety challenge of acquiring them and managing that kind of potential toxic waste. Here's the table of contents, and for clinical engineers this should be very pleasing and exciting. The main areas that we focused on, items 2.2, environmental considerations for safe home and community care. 2.3, managing human factors for home health technologies. 2.4, health technology assessment for safe home and community care. 2.5, health technology management for safe home and community care. And then 2.6 is actually quite important as well, infection control. One of the things that happens out of using medical devices for wound care, for tuberculosis, for COVID, is that a biologically active waste is generated. How is that handled in a community? We looked at the regulations across Canada. In some places, they said just throw it out with the regular trash. In other places, they wanted to have a separate disposal methodology. And then how do you dispose of the devices? In the U.S., we have a really crazy problem. When the Medicare system issues a device to an elder person, it becomes their property after 15 months. But they're not allowed to sell the electric bed. They're not allowed to sell the oxygen concentrator. It's considered government property but owned by the patient. How do you dispose of technologies like that? And during the pandemic, people got oxygen delivery devices. High-flow oxygen delivery devices, modified CPAP devices, home ventilation technologies. What do you do with them over time? You'll be delighted that the report is infused with the classical health technology assessment discussions. How do you choose the proper product for home use? An elder person, 80 years old, who may have macular degeneration and can't see at the central part of their vision, or cataracts, who may have arthritis or neuropathy and can't feel when they're trying to touch a screen, the use of a lot of touch screen systems is impossible for them safely. The management of alarms and alerts, the ability for someone to be able to replace items like batteries or filters. Some things are user replaceable. Other things require a technician or engineer. And different devices have different levels of complexity for that maintenance. Health technology management, boy, that's a real challenge. What if you're up in the Arctic Circle and you are in darkness for 24 hours a day and you have polar bears roaming the streets? You don't just drive to someone's house to maintain a device. You have to figure out strategies for swapping out the device, for providing loaners, for rotating devices through a community, creating outposts that can do maintenance. Now, realistically, that's how they do automobile maintenance. That's how they do bus maintenance. That's how they do snowmobile maintenance. But it is a real serious issue. Also embedded in these two is the fact that in the home setting, people don't necessarily even have home sanitation. They don't necessarily have sewage. They don't necessarily have fresh water. They don't necessarily have reliable electricity. You go into a lot of these homes, they don't have grounded systems. They have fuse boxes, old-fashioned fuse boxes, not circuit breakers. They don't have reliable electrical access. So how do you choose devices that are reasonably resistant and resilient for safe use? And the human factors engineering and infection control. Again, this report is, I don't know, it's about 120 pages. It's a free PDF. It goes into those in detail, and it also goes into the Canadian policies. And I urge you to grab a copy of this, and as you look at what you want to do in your own region or country, National Health Service, Ministry of Health, use these to help guide you and help guide your policymakers so you can make good decisions that are sustainable. Thanks. It's a great opportunity to talk with you. I don't have answers in this field. I have a lot of experience in this field, and I think that this is something we have to take as a very serious opportunity, not a risk, not a challenge, an opportunity that we have to grow into. Thanks a lot. So, our next, Ichio Watanabe? Ichiko, I apologize. I'm looking and my glasses are smudged. This is exciting because 20 years ago nobody did home care, and now everybody's doing home care. So we were learning from each other.
Okay, hi everybody. My name is Ichiko Watanabe from Japan. So I'm a clinical engineer, and I'm currently a master's student at Maebashi Institute of Institute of Technology in Japan. And I'm also a qualified care worker and work in the area of disability welfare. And today I'd like to talk to you about development of the power assist device for transferring patients with severe disabilities. So my study is slightly different from you, so it can be unique, but hope you could enjoy it. Okay, first, I'd like to give you some background information about this study. So medical care of the newborn has been increasing, and many high-risk infants are now rescued. Despite the children having multiple medical issues or severe disabilities, they are now able to live in their community with their family by receiving advanced medical care at home. Then, on your right-hand side, I will look at another thing, which is Japan's super aging society. You may have heard about it. Japanese average life expectancy has been increasing, and 1 in 3, you'll be surprised, 1 in 3 is over 65, which is the highest it's ever been. Again, I'm sorry, a little bit more. And then for the two topics, the significance of this is long-term care. So that means caregivers, mainly family members, get old as their children grow up. Then there's a problem having to provide care in a state of reduced physical fitness. Then the physical burden of caregiving by aged caregivers like mom and dad tend to become more serious. There are many nursing care tasks that require physical strength, such as transferring, bathing, changing clothes. They're quite hard to do. In particular, transferring can be heavy burden. So even though a wide range of equipment for reducing physical burden is available to caregivers, including, like you can see the picture, hoist, lifting slings, slide sheets, etc. Many Japanese people, Japanese caregivers are not willing to use those equipment due to tradition, our tradition, culture, custom, or can be a virtue. So Japanese people prefer to carry people manually. We still do. Okay, next slide, please. Okay, next, please. Thank you. Before going to the next main topic, I need to explain a bit more about the unique our culture. So we have the floor culture. Some of you have floor culture. So we traditionally, like you can see, sleep on the chair and eat on the chair. Sleep on the floor and eat on the floor and sit on the floor. So that's our traditional lifestyle. So therefore, high flexion, knee and lower back posture is unavoidable in our traditional lifestyle. So I look at those 3 points. Number one, we have super aging society and have to think about super long-term care. Number two, our unique thinking, caring with our own hand. And number three is our floor culture. So now I would like to move on to the next part and talk about wearable robot. Next, please. So wearable robot can be referred to be as wearable exoskeletons. Exoskeletons in my pronunciation. Okay. So just like in the movie, wearable robot can make you much stronger. They can provide support, reduce fatigue and risk of injury when lifting and moving heavy load objects. Some wearable robots on your left-hand side were actually they are certified as nursing care robots at the Ministry of Health. And then you can see another robot on your right-hand side. So that robot was developed by my university, Maebashi Institute of Technology. The robot is called LAD3. Well, actually, they are not currently widely used in nursing, even though they have been proven to be effective when lifting up heavy loads. The purpose of my study is to develop our robot LAD to be more suitable for the special requirement of lifting and transferring people with severe motor disabilities. Next, please. The lifting task can be divided into 2 stages, like a bending over and getting up, like 2 stages. And this wearable robot LAD3 had 2 control modes, a bending mode and extending mode, so which are effective when straightening our upper body when lifting heavy loads. Then I thought it would be nice if this robot could ease the patient transfer operation in home care. Okay, next please. Next please. Yes, the movie was here, I forgot, it's okay. So, on your left-hand side you can see me. So these pictures show how caregivers lift and transfer a patient from a sitting chair to a floor mattress, and I demonstrated the unique movement. So this young man, he's my client. So this young man has cerebral palsy and has severe motor disabilities. He requires full assistance when moving from the low sitting chair to a floor mattress. So what I'm doing that, so firstly I place my arm around his neck and my other arm under his hip. Then shift my weight to pull him and carry him up in my arm. Can you imagine? Then secondly, I turn my body toward the floor mattress. While carrying him, I'm still carrying him. Then finally, I bend my upper body and place him on the floor, on the mattress. So through this demonstration, I've examined how much wearable robot will be effective for transferring patients. So I put the robot on. So next, please. This slide shows the result of the demonstration of lifting patients with wearing LAD3. So, so you can see this one direction. So when shifting my weight to the right, like this, the power shift wasn't really activated. When crouching down, the metallic frames that goes around my back restrained my body movement, so I couldn't crawl down properly. Then, when I was kneeling, the frame behind the knee is stuck between the joint and its heart. Moreover, on your right-hand side, the belt loosened and the device slipped off the body after the demonstration. Next, please. So, as a result, the assist effect was not demonstrated in all situations. Because of the many twisting and turning movement, the strap was loosened and the device moved away from the human body. Therefore, the assist effect was not perceived. Similarly, the metallic frames and the strap belts are not stretched. They restrain caregiver's movement. Moreover, because LAD is designed for only forward and backward movement of the lumbar spine, the power assist had very little effect on lateral movement. And these results suggest that the first step in adopting the LAD3 for patient transfers is to improve the fixing method. Next, please. The exoskeleton for caregivers must be lightweight, compact, and easy to use. If not, the device could be just a hassle and unlikely to be used. We focus on movement of caregivers, specifically while lifting and transferring patients with severe motor disabilities in home care. As I discussed previously, lifting and transferring patient movement involves twisting, bending, forward, and lateral leaning. We've been currently working on this by using 2D and 3D motion analysis to estimate the body posture adopted patient manual handling. To be widely used and to assist caregivers for daily use, comfort is an important aspect. Currently, most wearable robots are seen as uncomfortable, especially for female users. Wearable robots must be developed to fit with daily caregiving activities, and I believe that improved wearable robots could make people with severe motor disabilities and their caregivers' life much easier and happier. Well, that's all. Thank you all for listening. It was a pleasure being here today. Thank you very much.
Yes. So, as the slides start to appear, we talk about home care. As Professor Sloan said before, our topic of home care is increasing in size at a pace that we can't monitor. So, we have a lot of technology, we have a lot of beautiful technology, but we have to put it into use, we have to use it accordingly and monitor how it is used in order to develop new technologies and to maintain at the best the quality of life of our patients. So, if you can please, okay. So, as I said, we have a lot of technology, we have the growing trend of avoiding long-term hospitalizations, and we all know why, because one, hospitals are not always available, because we can have a lot of patients, we saw with Corona, or we don't have enough space for a certain type of patient. We see in Italy that some wards are shut off or became smaller because of problems with funding. We also have an increase in chronic diseases. So our patients live longer, and it is a good thing, I think, but they are more difficult and more expensive to watch, to attend to. So we need a patient in the hospital, but we can't take our patient to the hospital. And we can only say, my dear patient, go to a protected residence, so a nursing home or something else, or we can put it at home. But as we know, at home we don't have much technology and we don't have much control. So home care, as we know, is the solution. But how is the area of home care growing now? It is growing, one, really fast, two, without much control, three, in my view, without seeing much, because we can't see so much about what other people is doing. We see in these conferences some examples, but every single health unit, local health unit, regional health unit does some projects, and we don't have a national registry of all the projects. We don't have, furthermore, a registry on a global scale of what has been done, what were the problems, and what were the solutions. So, how can we fight this problem? We can fight this problem in a first attempt, so as we are now, with a proper evaluation of technology. So when I have to make the effort to develop a new technology, to adopt a new technology, I use the moment to evaluate what is already existing, what are the needs of my territory, and what we can do in this area. This, in what I know from my studies, is called health technology assessment. So we did a little bit of research at the University of Trieste. We are now developing this area in order to obtain more results. So in Europe, health technology assessment is done from an initial point of view, so from 2005, at a European level. Why? Because we all have to do the same thing, so it's unnecessary to develop it 25 times, 27 times the number of European countries, and then say to the others, oh, we did in this way, it's different from yours. So we gathered together and we did one only method, which was presented by the European Network for Health Technology Assessment with the model UNET-HTA in the different core models. We are now using the core model 3. If you can please. Okay. We are now using the core model 3. Now, in the last year, the UNET project transformed. The project at the European level ended, so they took the opportunity to found a communitarian at level of the Europe Office for Health Technology Assessment, which is now taking its first steps in order to furnish, to gather all the information and to supply it to all the stations, to all the countries, to all the hospitals in the whole European Union. So, in this analysis, what we want to do? We want to try to transform the core model 3 of UNET-HTA, and we want to create a new standard for the evaluation of home care technologies in order to let everyone use the same model, and also in consequence to obtain results which are I missed the word which are comparable. Okay, so we don't do different analysis, but we do the same analysis even if I am in Italy, my friend is in Austria, and so on, and our results are comparable. So I can say, oh, seeing your analysis, I see that this project is also usable in my country, in my regional setting. Okay, the other things that we have to consider is that the system has to be easy to use, and if you can go in the, okay, and that we do a stepwise approach. Why do we want to do a stepwise approach? So not a single evaluation, but an evaluation subdivided in steps. Because normally, as we saw with some projects in our area, there is the idea from the hospital. It says, I have my patients which are in the northern part of the region, they are isolated, I want to do a screening for cardiomyopathies, so I do only ECG. Okay, what do we want to do? I want to do 12 things for this thing, and then they do the evaluation when they are trying also to create the final object. So there isn't a single evaluation, we have got a evaluation subdivided in time. So a stepwise approach can help us to gather all the information, but also to put in a rigid approach all the development of the final product. We can proceed, thank you. So we are going straight to the finish because I don't think we have much time. We have 4 steps where we took the core model of the UNET-HTA, and which is composed by some aspects. So we have the legal aspect, the current technology aspect, and so on. And we put the single domains into 4 areas. Then every single domain is composed of some questions, and depending on how we respond to those questions, we have a complete overview of the technology and the health technology evaluation. So we start with the aim, so the current state of the disease, the current state of the technology. We go with acceptance. As we said, there will be surely problems with ethics, with the legal framework, with the society, so the social acceptance of the technology, and with the country own specific safety regulations. So we have to develop our system regarding also those constraints. Then at 3 we have a first project which responds to a question, has some constraints, at the third level, we see what is around our system, so all the organization. So, for example, we have a telemonitoring system. We need to have a central with some people which responds to the telephone. It's not so easy to do if we don't know that it is needed, but it's essential. Okay, so we need all the organization and all the economic funding to do it. And then I put it for fourth stage, because we don't have much clinical evidence at the moment. We will have the stage of clinical effectiveness. In HTA, normally this is done to do a secondary part of the current technology. So we say there is evidence, so we can also do this. But in this stage, seeing that we don't have much clinical effectiveness data, because the technology is new, and the technology is a lot of technology, so we don't have the single cases in literature, we can only put it for last as a reminder to publish, to let other people know, to collaborate with others, and to spread the word. If you can go on. Thank you very much. This is the team who collaborated to the study. We are from University of Trieste. We will be there today, tomorrow, so feel free to ask everything you want. Thank you very much.
Thank you. Good afternoon. It's a pleasure to be here. Today, I will present about the research developed in Brazil. I'm Mariana. I'm from Brazil. I am a biomedical engineer. Now I am a PhD student at Biomedical Engineering Institute in Brazil, at the Federal University of Santa Catarina. Thank you. So, this work was composed this team by me, the Professor Renato Reda Garcia, and the three students. The three students in the different courses. So, Leandra is a student of medicine, the Alessandro Thomas is a student of information system, and João Vitor is a student of electronic engineering. It's really important because we are implementing a living lab at Institute of Biomedical Engineering, because we believe that it's really important to connect, to interact the different areas, to develop the different technologies from solve the problems from health. The Institute of Biomedical Engineering is located in Florianópolis, in the south of Brazil. About this work, it's important to focus in clinical engineering in home care. In Brazil, in other countries too, it's very common they act to clinical engineering in hospital, but it's needed to focus on other establishments like in home care. So in the clinical engineering in home care, it's really important to act in the health technology management. Today, we focus the participation in the management of occurrence of adverse events that may affect patient safety. Different from hospital, for example, there are many users that are new in health technologies. It's a big challenge for the clinical engineering. The goal of this project analyzes two reports of adverse events from devices used in home care, in focus on patients with diabetes. We've chosen 3 technologies: glucometer, represented in this first photo, the subcutaneous glucose sensor in the second photo, and the insulin infusion pump in the third photo. The final users that will benefit from this work, the patient, manufacturers, government agencies, professionals that work in the management of health technologies, health professionals, and other actors involved with health technologies throughout the life cycle. So, about the results. We selected 2 databases. The first was Anvisa. Anvisa is a regulatory agency in Brazil, similar to FDA. The second platform was MAUD, the FDA in the United States. Then the period of analysis was between 2019 and May 2023. The glucometer, so the total numbers of notification was 636, and in contrast, in MAUD FDA, 45,095. In the subcutaneous glucose sensor, the Anvisa, was reported 39, and on the other hand, the MAUD FDA, 1,078,607. I'm sorry. About the insulin infusion pump, not reports in the Anvisa. In contrast, the MAUD FDA, 313,892 and 892. We can see the big difference, the numbers of the notifications. There are many reasons for this. The culture is the main part of the difference. For example, the subcutaneous glucose sensor is not very common in Brazil yet. There are many reasons for this. It's important because the clinical engineering needs to improve, encourage, they create actions to improve the notification, the adverse events, such as hospitals, such as a population, the user common. There are many limitations for this work. It's important to talk about this because we are seeing the data, but we need to focus on the quality of these data. So there are many lack descriptions of the data from notifications. It's a really problem. They are underreporting. It's really important too, and the lack of standardization. It's so the 3 main limitations that this work. We analyzed the problems specifically in the MAUD. So about the glucometer, we analyzed the failure to turn on, incorrect or inaccurate results, high test results, and difficult to read display. About the subcutaneous glucose sensor, the main problems were wireless communication problem, no device output, incorrect result or readings, and inaccuracy. About the insulin infusion pump, the main problems were interaction problems with the patient, breakage, energy and mechanical problems, and difficult in programming or calibration. We analyzed the recalls in disparity. In disparity, 12 recalls were found in the FDA referring to glucometer, 11 to subcutaneous glucose sensor, and 3 to insulin infusion pump. The main reports were related to the battery, use of the technology in environment conditions that can cause inaccurate results, in the cybersecurity vulnerability. We analyzed the effects these problems in the patient too. So the hypoglycemia and the hyperglycemia. It's really important because the results of this medical device is used in the making decision, in the decision making. So it's really important to focus in the strategies to improve the better technologies, with the better design these technologies for the reduce these risks for the patient. So the clinical engineering medical devices used in home care. Technovigilance, this work reinforces the importance of the technovigilance, highlights the need to encourage the practice of the reporting to generate evidence. We need to create actions to improve the notification of these problems, the notifications of the problems about the interaction with the human, with the technology. Analyze the cause and effect is a relevant tool for the health technology management to create preventive actions. Usability, considering different users, it's really important to consider the diversity of the population. Brazil, for example, is a big country. There are many different populations with many different cultures. It's really important to consider this diversity in the country, in the different countries too. And metrology, we need to guarantee the reliability these results. It's really important to focus in metrology in the home care too. So we are using these data, but we need to guarantee the quality and the security of these data. Education and training, education, the different professionals, different users, different persons that use this technology, is we need to develop the training, focusing the user that use this technology. Connective, we are seeing the connectivity between the different technologies in home care too. So we need to focus in cybersecurity and the data security also. And finally, predictive management of health technology projects in the oblique scenarios. So there are many opportunities for the health technology management in home care, but we need the clinical engineering needs to focus the energy, the actions to improve and make their use safer of the technology management, the health technology management. Thank you so much, and have a great group session.
Crisis issues and catastrophes. We have problems every time there's a catastrophe. People who are at home with blood glucose, with oxygen concentrators, with wound care systems, we don't have a way to help them. And for weeks, sometimes months, they don't have the care they need, and some die. So this might be another team. If we're talking about creating a team of experts, what should we do to help provide support when a catastrophe occurs, whether it's an earthquake, a hurricane, or any other catastrophe. Because the more people we send home with acute care devices or in community care settings, the more we have to figure out how to reach them in their time of need. So the next presentation is from the UK. It's related to remote monitoring. Do we have the presenter here? Remote monitoring for COPD patients? Do we have that presentation? But we don't have the presenter. What is the presentation after that? It's not it's narrated. Okay. So you can just run that. don't have it in the multimedia? All right, so let's skip that one for now. Then from Somalia, Saeed Ahmed. Is that recorded? We don't have that. Status of medicine, regulation, and the risk of substandard medicines. So then we have from Lebanon, Sandy Rihanna, virtual clinic implementation.
I'm honored to address today the International Clinical Engineering and Health Technology Management Conference, discussing the topic of utmost importance in our challenging times, the virtual clinic platform. I'm Sandy Rihanna, biomedical engineering professor, healthcare technology consultant, and stagnant dev at World Health Organization. The COVID-19 pandemic has left an deep mark on the Middle East and North Africa. As of October 18, 2023, over 20 million cases of COVID-19 has been reported in the MENA region, with more than 200,000 lives tragically lost. In fact, the impact of this pandemic has been profound, affecting the lives of countless individuals and overwhelming healthcare system. However, the challenges in the MENA region extend beyond the region faces a high prevalence of chronic disease such as diabetes, heart disease, cancer, impacting more than 39 million people. And all these patients, along with the elderly, were particularly vulnerable to COVID-19, and they have been understandably cautious about visiting hospitals to receive the care they need. There was a need for solutions that can bridge the gap between these patients and healthcare providers. This is where telemedicine and virtual clinic platforms comes into play. Telemedicine leverages technology to deliver healthcare service remotely, and virtual clinic platform represent one facet of this approach, allowing patients to consult with medical professionals online. Recent studies, such as the one conducted by McKinsey, have shown a remarkable surge in the adoption of telemedicine since the onset of the COVID-19 pandemic. The study revealed a substantial increase in the number of patients and medical professionals embracing telemedicine. The number of patients using telemedicine increased from 11% to 76%, while the number of physicians adopting telemedicine grew from 69 to 96%. In fact, the advantage of virtual clinic platform are numerous and vital, especially in the context of the MENA region, where they are convenient, accessible, affordable, safe, and allowing to measure multiple vital signs and to data log and telemonitor. Our platform records and logs temperature values, airflow data, blood pressures, and allowing that thus for the creation of visual charts and trends to assist in diagnosis and treatment plan. Our virtual clinic platforms goes beyond more consultation. We offer an integrated system that includes registration, electronic patient record, vital acquisition, and healthcare provider can monitor their patient through a user-friendly mobile application or web platform. I'm honored to address today the International Clinical Engineering and Health Technology Management. part is its unique competitive advantage. We offer a multilingual environment that combines various features to provide comprehensive healthcare solution. Our platform is Telepocrat, designed to bring healthcare to people regardless of language barriers, ensuring that everyone can access the care they deserve. This project, as similar to many others, is a testament to the power of technology and innovation to transform healthcare delivery, making more accessible, convenient, and affordable. Thank you for your attention and looking forward to engaging meaningful discussions and collaborations about the potential of healthcare and technology to transform the healthcare system.
So that was a little hard to understand, and we had a gap there, and I think they might have been using the product called Teledoc, which is a commercial product, so we could probably look up more information about what Teledoc does in the service. Hugo, I think you're next. Come on up. And when you're done, we'll go back to the one presentation we have in PDF and maybe at least discuss what they provided.
Good evening, everyone. I'm Hugo Gonzalez from Mexico, from the University of Guadalajara, and I think I'm gonna thanks. I think this presentation is gonna be a little bit different. I'm not gonna present a technician paper per se, but what I'm gonna do, I'm gonna talk about the perks of developing a healthcare technology startup as a college student in Latin America, more like the history of 4 years of work that we have been doing in Mexico. Well, have you heard the phrase that if you want to go fast, go alone, and then if you want to go far, go with your friends? Well, my friends and the people that are behind this project is MBA Eduardo Mendez Palos, Pedro Misraim, who are teachers in the university, and they start as my mentors, then my professors, and then as my friends and my colleagues. Ricardo Manuel Garcia Manso, Felix Antonio, and Jessica Gabriela. Specially designed technology for the elderly human body is the next step to prevent the future crash of the national healthcare systems. Do you think why this could be a problem? We have heard of the problem, the case in Japan, that 26% of the population is elderly of 60 years more, while in Mexico that amount is around 12%. And why is that a problem? Because the technology that we are developing is not made for the elderly human body. We can see it, for example, in when we touch the hands of our grandparents or of loved ones, that is cold. And why is cold? Because the blood is not getting through the extremities. So in the market, what is in the market, in the easy access market? The smartwatches. Which one? The Apple Watch, the Xiaomi, another brand, no? Not all of them are medical devices per se. I think only Apple Watch is the one that is going through that category. But we were trying with BetTech, that is the name of this startup, of this try of startup, because it was a pandemic and we were working with elderly people, so it was one of the population that we couldn't work because they have to be separated because of the illness. Well, this BetTech startup initiated a student project to take care of our loved ones. Actually, this project started as with my grandmother, that she felt several times, and there was one time that we didn't know until 4 hours that she was in the floor, and nobody could help her. There's a problem when we try to develop new technology for the elderly people, and at this moment, is that because when they were young, they didn't have the technology. So we have this first barrier that they have to get to know and to accept the technology. not all the people is aware of wearing the smartwatch, that they have to charge it in the night, then put it again in the morning. So that's a problem, no? So we can do with this idea. What if first the thing with the blood not reaching the extremities? What if we make the measurement in a centralized way? That's the thing that we have to design. The second, how can we make that device in a wearable way that they are already using well in the clothes, in the underwear clothes? We have two goals, actually three. Two of the project, one of this talk. The first one of the project was to help the elderly people in a personal way, to help my grandmother and a grandparent that has blood pressure issues. The second one was to make a lot of money. We wanted to make a lot of money because we thought that the medical device industry, it was easy to get into in Mexico. We were wrong. The goal of this talk, of me talking here, is to give you not only in Mexico we don't have precisely only in the soft part, I think so, the clinical engineer specialization, but how can we universities, because all of the universities already have heard of we have to innovate and we have to make the people, the students, to have not only the thesis and in the paper, they have to make the transition to an enterprise, but it's not always like that. How can we do it? So in this talk, what I'm going to try to do is not only have to make the project into the final project to the cell, but how can we make more of the students in their 4-year lifetime? A little bit of the project. Right now we are in the TRL level 3. We are working to getting to the 4, but we have several methodologies that we were working that we have to learn how to use it. First, we have to see if the problem, what problem do we want to solve? In my case, I wanted to help my grandmother and my auntie that she was taking care of. Then research why the problem is a problem, because not all the problems is a problem because they perhaps someone in Japan, someone in France, they already have a solution. Then we have to ask ourselves in this case, can we take care of older people 24/7 with the technology designed for their needs and with the body's limitations in mind? Then we have to look how is the people working right now with that problem. For example, in the countries that are in the developing ways, most of them can pay for the technology. So how can I take care of the elderly? Well, I put someone of my family to take care of them. Then I have to look in the fundamental ways. Oh, that's the way down. Do a field research on the industry, nursing homes, Mexican household with older people living with a nuclear family. We have different opinions here because we were asking at the homes, do you want a technology for you to take care of your loved one even though when you're not there? And they were like, no, I want to take care of my dad, for example. I want to take care of my grandma because she took care of me when I was young. Or it was not because of the technology, it was more of the affection side. And then we have to define who is the client, who is the final user, and who are the potential partners. We're talking about the familiar part. So, for example, who was the client? In this case, the familiar or perhaps the nursing home. Then who was the final user? It was the elderly people or was the person who was taking care of the elderly people? And then who are the potential partners? In this case, we were working with nursing homes and hospitals. Some results of this 4-year project that we have been working. I'm going to read this really fast. The development of the startup BobTech has taught us that with a sense of purpose, American engineering students can develop tremendous opportunities for themselves and their communities way beyond the topics taught in the classroom. with no limits of evolution, but also taught us possible limitation on developing the project that needs to be taken care as mental health, the balance between the school work life, the project, and the personal life, but more important, what can we do as students? What can we do as biomedical students in an undergrad program? For example, and we have this phrase because at this project I started with Jessica, and then we invited the professors from the Rocky Mountains through the desert of the Sahara and now to the Middle East. We have get with this project, not only because we develop that kind of projects, but for example, also her and me, we are gaining more of the double of classmates that they are making. Why? Because we have 4 years of experience working with projects, working with people, working with the healthcare systems. We knew what has to be done in Latin America. And why Latin America? Well, during this project, and due to the project, we were in a meeting with doctors, for example, in this kind of environment that we didn't know what we were talking about. We were tremendously nervous, like me right now, because we were talking with people that know about the project, the problematic, and then they start see us like, okay, they want to work. So we start meetings with students from Brazil, students from Latin America like Peru, Ecuador, Chile, Argentina, all between the, have you heard IEEE MBS? Well, I was the first student representative for Latin America, but due to the project that we started 2 years before of that. And what, was not like, okay, you're gonna be. No, I have to compete with other 2 students that wanted that position because it was the first time that we was doing that. We ended in a talk with Adriana from the WHO in the 4 International Student Conference, which I was a co-president of all of that because of the project. But my friend, she was also starting as a community leader, ended up in work in projects in Spain, working with people from Brazil and from Chile, and not only that, then she started moving to Africa to start these kind of projects too. So the end up to end this talk, how can we increase the clinical engineering in our students when there's no clinical engineering program as per se? Well, okay, start a company. But as a project, you can start a company, and then you're gonna see that, for example, when you're looking for news to see if there's a problem or not solved, you can see that, for example, in the United States, only the last year, the industry of death care was $20 million. And I'm not referring as how I'm gonna take care of the ill people. No, I'm talking how I'm gonna take care of the body of the dead people, and that's completely what kind of the medical devices I'm gonna use to process the body. If I'm gonna take something to put in another body, or for example, in the sexual industry, which is an industry of $16 million only in Mexico in the last 3 years. All of that, we can see that the medical engineer, not only clinical engineer, is so far and so big that we cannot teach all of that in one class in 4 years. We only can teach and get that information when we are doing the projects. So thank you so much.
Presentation number 3 from the UK, and let's try to at least illuminate what our UK presenters wanted us to know. Apparently, we got the PDF, but we didn't get the multimedia version, and maybe that's out there somewhere. If it is, we'll try to make it available in the proceedings. Okay? So evaluation of technology-enabled care for remote patient monitoring of COPD in West Wales. Next slide. We have 4 co-presenters, Tritech Institute in Highwell, DDA University Health Board. That must be a regional university health board. Next slide. Technology-enabled care, monitor patients remotely in rural areas. Common to every country, there are rural areas that are not easily supported from the urban centers. Looking at remote patient monitoring and COPD, chronic obstructive pulmonary disease, heart failure, and interstitial lung disease or tuberculosis. And adoption of RPM programs could have the potential to improve management of chronic conditions. And obviously, chronic conditions, we want to keep the patient out of the hospital and having as much quality of life as possible at the lowest possible cost. Next. So real-world evaluation and mixed methods, quantitative and qualitative measures to evaluate implementation, benefits and benefits or disadvantages. Interviewed via telephone and invited to share their views on what they liked and disliked about the service. And patients invited to complete a survey to share their satisfaction. By the way, there are a number of surveys in the Hacking COVID repository. There are more than a few user surveys, satisfaction surveys for telehealth, and it really varies widely. Pediatric care is one area. Geriatric care is a different area, and understanding the difference is important. Clinical staff interviewed and invited to share their experiences, enablers, and barriers. Next slide. Patient feedback, 106 patients, that's good. 8 GP practices and 1 chronic conditions nurse and 35 patient interviews. Now remember, the UK environment is rather unique. It's a primary healthcare environment with primary care physicians in almost every village and providing a lot of preventive care and intervention. So this is the National Health Service and the version of it in Wales. They had 30 patients with positive feedback. They had 31 patients, 89% wanted to continue, and 24% felt they got better access to care, 69%. 5 patients, 14% were dissatisfied or less positive, more flexibility with readings, so the time frame was annoying to them, and notifications or results have been seen. So they didn't feel they were being tracked. I know in reading a lot of these other articles, there's sort of some patients really want to have a human being, and some patients even want to see a medical doctor, not a nurse or an aide. But I think in the UK system, they're more used to having an intervention of a care team, not just the physician. Next slide. So found equipment easy to use. Quite a few look like they agree and strongly agree. You're talking about over 80%, 85% found the equipment easy to use, but they don't tell us what equipment. They don't know, if there's oxygen concentrators or liquid oxygen or exactly what they were using. Useful for managing the condition, it's 65% agreed or strongly agreed. Reassurance and peace of mind, that's a pretty big number, up to 80% in terms of reassurance. And made lifestyle changes, that's more like 50% made lifestyle changes. And so, again, COPD, I'm imagining patients who want to be relatively active and are probably using oxygen supplementation of some sort, and I don't know what they were provided. If they don't have portable tanks, then, or portable oxygen concentrators, they're not going to be able to travel very far, do shopping and other activities that they might want to do. Next slide. Help clinician understand changes. We're up to about 75%. Take my medication more regularly. We're down at 40%. Now, this is another aspect that I didn't mention that comes out in the first project for the Canadian Standards Association. There are a lot of side effects of medications for patients. It makes them feel uncomfortable. They have cognitive effects. They're confused. They're sleepy. And so there's a lot of resistance and sometimes resentment for the medications that they have to take, and it's sort of a tug of war that goes on. So compliance with medication is a challenge, and especially since many patients, and they don't tell us here, were the patients pure COPD, or do they have COPD and diabetes and neuropathy? What are the combinations, or what other medications might they have been on? My health has improved. Well, that number is not very big. If you have COPD, it's a chronic condition, and you're slowly degenerating, and so you don't, your condition is not going to improve. Quality of life, would they recommend? That's a big number. Almost 80% said they would recommend it. So they're aware that the alternative, if they didn't have this care and the remote monitoring and the support. So I guess the environment I'm picturing is they have whatever medical care, medication, concentrators, maybe infusion devices or whatever other support. And this is a remote monitoring environment. So it is, they're tethered to a coordinated care system of some sort. We don't see what that looks like or how that's done. And if it's a lot of human interaction, it might feel a lot better than if you're just typing information into a tablet or responding to a poll by text messages. I don't know about you, but I get kind of aggravated when the hotel sends me text messages, "Are you happy with the hotel?" It's like, is there a number -5? It gives me choices that aren't particularly useful. In fact, on the flight over here of Indigo as a diversion, when it landed, a poll showed up asking me to rate it. So it also happened on the flight over on Emirates. As soon as I landed, there were a bunch of happy faces for quality of the staff, quality of the food, comfort. It was kind of interesting that they would push that on you, but I answered it anyway. I was pretty happy by and large. Next slide. Staff feedback. So they asked the clinicians, 5 nurses, 2 assistant practice managers, 1 practice manager, a pharmacy technician, and a community nurse specialist. So there's no medical doctor in this particular care paradigm, and they wanted to know how did it work for them in their telehealth system. Next slide. Barriers to adoption, technical issues, Bluetooth, user-friendly, and the software, notification for systems. Has someone looked at my data and, I'm having trouble breathing and I'm not getting anyone to respond. Lack of systems integration. Patient compliance is always a big issue with patients that have chronic illnesses because they're uncomfortable, they're unhappy, they're confused. Just like too many PROM questions, I'm not sure what that means. Too much hassle, digital literacy of end users. Well, that's something that Dr. Coley and I have talked about. Digital literacy is for the clinical users, but also for the patients. If you're talking about 85-year-old patients, these folks are not used to using computers. They're not used to using text messaging. They're not used to reporting units of measurement like pulse oximetry, percentage of oxygen, or respiration rates. And they may not really understand why they have to take the same readings a certain time of the day every day in order to have something that matches their circadian rhythm in their life. And then infrastructure, time for staff to monitor the system, increased workload, pressure to deal with alerts, poor communication links between stakeholders, and poor communication around flexibility of reading times. And of course, communication among stakeholders is a significant issue in healthcare in general. The handoff between different participants in healthcare is one of the classic areas where we have problems, and problems emerge. As a patient goes from one specialist to another, as the patient communicates something to their caregiver, who then tries to put it into the system, who then it gets to somebody who's on holiday, and the person who's answering the question is not their usual clinician. There's a lot of gaps that happen, so continuity of care is a big challenge around the globe. Next. Enablers, technology and user friendliness, improved integration with the National Health Service, inclusion of more digital materials with the software. Who reads the instructions? Not many of us. Who has time to look at the instructions and help screens? And when you go to the help screen, you don't even understand what the help screen tells you. And it doesn't match the version of the software you have. Expansion of scope of service, infrastructure, more support and guidance, protected time for staff to monitor the system. Well, that's another problem. I mean, physicians and nurses are being asked to monitor more and more patients with less and less time. This begs for an AI tool to help more intelligent triage so that the clinicians know which patients are getting sicker, which patients are getting better, which patients are stable, so it isn't consuming as much time. We see more and more chatbot kinds of tools. And I don't know if I'd like that if I was a sick patient struggling to breathe, but we may need tools like that. And the staff is being overworked, and this is like round-the-clock support. Better communication, better with patients, flexibility of readings, patient notifications, early patient support to ensure they're using the system, focus on patient mental health. That's a big issue, mental health, depression. A lot of these folks go through cycles of depression and confusion, and helping them with that is something that is part of compassionate and ethical medical care. Inclusion of links in the software for guidance to manage anxiety. So those two are kind of linked. When you're having trouble breathing, you get anxious because if you go into a crisis episode, you're going to the hospital, and you're frightened, and if middle of the night or a storm, your anxiety is ratcheting up very, very quickly. Fewer prom. Does anyone know what PROM, the abbreviation there is? I don't know what that is. Patient reported outcome measures. Okay, so that's the acronym. So are you feeling better? Are you feeling worse? Are you having more side effects, less side effects, etc. Next slide. Overall, patients with COPD reacted positively. The satisfaction was high. Majority of patients finding the service useful for managing their condition. I think that was true in a lot of the telehealth examples during the pandemic. Of course, that was sort of a forced choice. You either had telehealth or nothing. So, it was certainly far better than nothing, and certainly far better than going into the emergency department with a lot of people who perhaps were having scary crises. Staff views were mixed. They could see a potential, reduced workload, well, that's a balance, concerned about the time needed to monitor the system, and future work, focus on determining if the perceived benefits are reflected in improved patient outcomes. I mean, we're all kind of the slaves to our smartphones, right? Text messages, WhatsApp, phone calls from family and friends, emails, 5 different communication channels, and this is just the world that we're living in. We have to figure out how to get a better handle on it. Next slide. Okay, you can correspond with Dr. Hopkins, Dr. Davies and Dr. Hopkins, and get further information on what they're doing, and this is really an interesting presentation. I'm glad we spent the time to go through it. So let's open up the floor for questions and discussion. We have time to talk more about home care and the challenges, solutions, needs. The floor is open. We have our experts here. Yes, please. Here, let me give you the...
My name is Carol. I came in a bit late for Chico's presentation, but it was very, very interesting. I understand that you're at the development stage. So what's the plan? Like, do you see it as commercialized? Do you have commercial partners to work with?
Thank you. Developing robotics is not like we can do like very short span. Could be decades to be commercialized. Well, so we have, I call the robot L83. Yeah, of course we had 1 and 2, and this is the latest one. And we are going to make the 4th generation. Then, well, at the moment we haven't got any sponsor to make it commercialized, but hopefully I'm hoping to do that.
Fantastic. I've got one question for Mariana as well, if I may. The glucometer, did you actually look at the pattern perhaps in a particular brand of glucometer, or was it just a whole range that you looked at it? Did you look at a particular brand of glucometer? Did you actually go further down in the results when you were looking at the database analysis?
The question was, did you look at the different brands in the MAUDE database, or were you just looking at the broad category of reports for glucometers?
There are many categories about this technology. It's a big challenge because there are many codes in these platforms. Because, for example, on Visa, there are many different codes for one technology. In the FDA, the same. They are different, but for example, the glucometer, there are 2 codes for this technology. The sensor, glucose sensor, 7 different codes for the same technology, but they are different codes. The insulin pump, one code.
But the question was, did you look at Abbott versus Roche? Did you look at the different companies? Did you distinguish between the companies?
Okay, the MAUDE, yes. The MAUDE, we can see the different companies, but on Visa, it's not possible to see the companies about this because the security of the data. But we not separate with the analysis reference each technology with each company. But it's important, it's a good idea to
just for
analyze.
the pattern of whether one brand was more reliable than the other, perhaps.
Yeah.
Thank you.
Yeah, there's another hidden flaw in the MAUDE data, which is that the manufacturer reviews each of the reports, and if they determine it was a user error, the user didn't put a battery in, or the user didn't connect the leads properly, their legal team may say, well, this is not a reportable incident. It's just a mistake on the part of the user. Well, they dropped it, and it broke. So there's missing data. It's not being handled like a consumer product right now. It's straddling an area of reporting that is unfortunate. Other questions? Other thoughts? Other ideas? This is your opportunity, international discussion.
Great presentations, everyone. Questions for Hugo. From one college student to another, I know how hard it is to get funding and everything. So what's your plan to commercialize it as well? Like, what's your go-ahead plan for the future with your startup?
Yeah, actually, with my team, we are starting a university laboratory. I write it because it's in Spanish, but it's a laboratory for innovation in biomedical technology and health management. We are not trying just to do that. We are going to start developing now that everyone is doing even PhD or master like me. But we are trying to make other projects that are perhaps more easier to do, because this one has to do with a lot of data, Mexican data, that we don't have. So the first step is to gather this Mexican data, but in the meantime, we are going to start working in our master's and PhD projects. In my case, is in hyper-chaotic systems, but for economics, health economics, or everything, again, because of this project. Yeah. Thanks.
Thank you very much, everyone. I would like to ask all of you about regulation approval, because in Japan, home care medical device have a strict rule more than ordinary medical devices, because user is different. Usually, medical device in the hospital use a physician or a technologist, so they know how to use. They know everything. But like a home care device, usually patient, family, or take care worker, and they, as a less, knowledge and experience, than hospital medical device medical people. So in Japan, those home care device have a strict rule than and the ordinary medical device. But I think it is we understand, because safety is the most important in home care medical devices. But it will be hard. I mean, if policy I think policy need to change because, because of course, okay, ventilator, yeah, stop the patient breath. So yes, but like a pulse oximeter or something like assistant devices, I think government should reduce, some policy or something like that. So I would like to ask all of you, your country, what's the policy or what's the strategies government have about regulation approvable? If somebody have. And could you let me know?
I don't think I can give you an answer. But in Australia, it's actually the administrative burden and actually ability to provide any solution is getting worse. For example, it's only like 15 years ago, clinical engineers were able to in-house do R&D, and if there is not a commercially available product available, they would usually go to the workshop and ask, could you, we are doing a trial and we want something built. We'll do a couple of prototype. Now our regulators, Therapeutic Goods and Administration, last year they've even introduced, so we were exempted. So it was, if you are working in a public health and you're doing it for, I guess, community service for the hospital and not commercializing and helping a clinician or a hospital or whatever, you were exempted from, there were requirements. You had to document your design, you had a biomedical engineer review it, safety assessment, it was okay. Last year the regulation was changed, so we are basically made it very ineffective, because what they require us to do now is even if you're doing R&D in your hospitals, in a public health hospital, they expect the same level of documentation and registration as they would expect from your Philips and GEs and the commercial vendors, even though we are not making any money out of it. And that's been, there was a huge outcry from the whole country, and they're reviewing that legislation now. So if I do something for my cardiologist that I would do normally as a business as usual, I now have to register it, provide all the documentation, and have the whole administrative burden that doesn't encourage us to actually do anything. So I wish I had an answer. It's actually, in our country, it's actually becoming difficult, not easy.
That was where 40, 50 years ago biomedical engineering
You made me think of some other aspect that happens in many countries, including mine. Government realizes that there are trending topics that have to be prioritized and decided to move forward, but not in an intelligent way. An example, Mexico, this government said everybody's going to have free internet everywhere in the country, even in places where there is no electricity, and in places where people don't know how to use a phone because they are very old. No? Then it comes COVID, and government says, okay, it's important to have telehealth and teleservices and everything in between. Let's move forward to this scheme. Fortunately for us, we have a Center of Cenetech, or Center of Excellence in Technology, that now has a new director who's a physician, but he is also very open to clinical engineering initiatives, things that didn't happen in the previous years. So in this time, we are moving forward to attending topics like the ones that were said here. And in this sense, I think the concepts and the frameworks that Francesco presented are very, very important, because it is HTM for a new framework. So this framework has to be understood by everybody, not only us. So in that sense, as long as we have, and we develop more evidence, practical but also theoretical, and the topic will be better for us to suggest solution, and for the decision makers to understand them and to listen to us.
Thank you. Dr. Coley?
I just want to reflect on your comments about the usability and regulations. It's very interesting. I've had a privilege of looking at facilities across the world, and one example clearly stands in mind where a very famous EMR out of the U.S. It has a reputation of being a great EMR from a billing perspective, but from a usability perspective, there are challenges. The same product deployed in Australia is loved by the clinicians. And the key difference there is regulations. In the US, regulations require us to document a lot. And to the point that in a clinical space, EMRs have become a dysfunctional communication tool. Doctors dream of the day when you'd get a note from a specialist, primary care physicians would get a note from specialists and vice versa, where you'd have an assessment and plan, and you'd know exactly what needed to be done. So there was continuity of care. This day and age, you get a 50-page note, but you really don't know what the communication is. In Australia, it's a hospital in Melbourne, they said we use this for complex care coordination. Our regulations do not require us to over-document. So I think the moral of the story here is that every system is perfectly designed to achieve the results it does. And I think we tend to think about medical technology or health information technology, or name your choice of technology in healthcare in a relative silo. And I think we really have to look at which environments and which use cases are the most appropriate for that. And I think we have a couple of startups here. One of the things that, as I advise startups, we look at, right, are there environments where the regulatory landscape is a little bit more permissive, not to the detriment of patient, but really it allows you to innovate versus the other. So I think in forums like these, my wish list is that we really need to sort of have a strong presence of payers and regulators, because I really think we need reform in those spaces at the same pace as technology and medicine are evolving. Right now there's a disconnect.
That's an interesting observation, because 15 years ago we were looking at Australia as the leader because Australia was innovating far faster than the U.S. We were seeing products being released and proven in Australia, and the U.S. was, well, what about us? because our systems were so slow and cumbersome. So, another possibility for us to talk about with our global community, and the presentation I did earlier about LMICs, is finding partners in other countries who can work with you to help prove technologies. Now, again, I'm not saying to do unethical things. You have to do these things ethically and safely. But if you have a university hospital center and a qualified, bona fide medical team and partner, then maybe there is a way to accelerate through partnerships. And it becomes a win-win or a win-win-win with entrepreneurs who can help translate those into actual products. Yes, you can use that button if you want.
Try. I think if I'm right, you probably we adopted EPIC in Canberra, and that's from the learnings from Melbourne. And we went to go live last year, and personally I was part of that team because we went for a full medical device integration. And it was even though as a global community we refer to ECRI, AAMI standard, and theoretically we feel quite connected with US, but it was quite interesting going through the EPIC experience, how different the culturally we were, even the thinking of the way. And it was quite frustrating for the EPIC colleagues because they obviously were sleep deprived as well because of the time difference, but they were, the number of things that we were asking or just sort of throwing it out of and they were trying to say, you know, we just couldn't do that in US or, and it's actually quite interesting. There's a lot of things that we had a lot of resistance earlier on because there was I don't want to insult our colleagues in US, but this is a very Americanized system. It doesn't align with Australian way of doing healthcare. But it was interesting to observe how there are aspects that were very similar, but there are aspects that are extremely different. And EPIC, to their credit, they were absolutely fantastic. They created workflows and modules for us. And at the moment, we're going through our major project of actually implementing a closed-loop medication system. And there's a lot of things that EPIC can't do that we want to do from the patient safety perspective, and they're developing it. And we've got a company, infusion pump partner, that's the first one in Australia as well. I don't know why Canberra seems to do that, but there's a Swiss company. And it's amazing the collaboration of the 5 different ICT colleagues like CBER Integration, our Capsule and EPIC partners. And in that forum, for the first time, you feel like you forget there are contractual partners, like we have a transactional relationship with some of those. And it is quite delightful when you have that collective input, and something that comes out of is actually, we went go live last year, so this November is 12 months. And we are going to the next big adventure with EPIC on our closed-loop medication, because medication safety is our accreditation standard. So I can't wait to share that with you because it's been a painful 2 years to get to that point.
That's a good point, and your mic may be on also. However, this is a slippery slope. Cerner, who has all of the contracts for the Department of Defense and for the Veterans Administration, has been hard-pressed because every different hospital group wanted to have things customized. Now, just think about if you got in an automobile and the steering wheel was on the side of the door and the other steering wheel was in the back seat and the other one had a key in the center like the Saabs used to have, you would be pretty frustrated pretty quickly. And if you think about the trade-offs in software, and I've been in software engineering for many decades, sometimes we need to adapt our business processes to the systems. And to your point about testing and HTA that can be used in other countries, if we allow too much customization, bad things can happen. Patients were killed in Philadelphia at a VA hospital because each physician had a different order set. They could change the order sets for radiation treatment of prostate cancer, and one physician kept changing the parameters for where the placement of the seed was, and eventually patients died because they were allowed to keep changing it. So we're going to have a kind of a group think here and try to come up with some more standardized systems, because if we all build systems that exactly do what our past systems have done, we could be building ourselves into a corner, trapping ourselves.
I think it's a perfect tee up for another session. This is a 2-hour discussion.
But going to your point. Oh.
Yes. Oh, she's speaking.
Going back to your point, you're absolutely right. We actually had areas like radiation oncology, for example, and we actually started off with the clinical engagement. So we went from, rather than jumping on the technology, we went at defining what a medical record looks like for us. And a classic example is radiation oncology uses ARIA, and it's very integrated. They were always paperless. They've been doing it for years. They actually changed. They gave up their existing processes to streamline with the rest of the, and they openly said, well, it's sort of like a semi-step back, but we're willing to take that. So we actually, for the interest of that patient safety and workflow, there are areas of clinical, because we did it not from the technology jumping perspective, but building it and then looking at the technology as a secondary component of that solution.
Right.
Yeah.
How much time do we have? You know, I like a couple of words that were used. I think partnership is really important. Enterprises that are successful, technology suppliers who are successful, generally have a very special relationship where they are committed to a shared success. I think gone are the days where you're selling a gadget and you're done. I think healthcare is too complex. While 60% of healthcare is probably uniform across the globe, 40% is, the localization and the regionalization piece, and that has a huge impact. So if there was a recipe book, I think we would be billionaires. We don't. But I think Epic has done a good job as a vendor to play the role of a partner. I think what they've brought is some structure to harness healthcare. I think we are guilty, especially we physicians, because we all think that the best way to practice medicine is one way, which is my way. So you multiply by the number of physicians, and hence you get the problem that you have. So, I was at the Cleveland Clinic, and one of the things that was really well done there was care pathways. So if we can agree what's the best standard of care for heart attacks, stroke, name your condition, and then you begin to apply that to patient. So this is really where you get into precision medicine, and because there are so many variables involved, a strong information system really helps. And that's really where information technology comes in. Information technology combined with standardized care processes and then customized for the patient is really the golden ticket. But it's complex. It is not a one-time sale, one and done. It really is a commitment, partnership. And I like what you said earlier. Others have said it. The thing that's unique about healthcare that we're all consumers and we're all suppliers. So for us, it's a privilege to do so. And the other word that I really liked you said was adventure. Yes, there are challenges in healthcare in every geography, but if we all approach it as an adventure, it's a lot of fun. It really is.
Now it's on, sort of. But let me explain who this gentleman is, who this friend is. This is Dr. Manish Kohli. Dr. Kohli is a physician. He was also the Chief Medical Information Officer for the Cleveland Clinic Abu Dhabi when it opened. So he understands the culture of perfection that the Cleveland Clinic has, and also the blending of cultures. He is also the past chairman of the Global Health Information Management and Systems Society, HIMSS. So he has spoken around the world about health information management systems, and he is a strong friend and supporter of GCEA and IFMB CED. He was at our Rome conference and also at our Washington conference. And so what you have in Dr. Coley is an expert that you really should get to know and cultivate, because we need more people at this level who have access to policymakers around the globe. Corporate, he knows the people in all these big companies and he works with them, and he's also created a new foundation, the Pull Alliance, which is an organization that is working towards bringing digital health to disparate, underserved communities. And so, part of his heart of gold is really looking at improving healthcare around the globe using these technologies. But his brain of gold is full of tremendous knowledge, both in the technology side and as a clinician. And we're delighted to have you as a friend and partner and collaborator. To all of you, thank you. It's been a great exploration of home care. And this is part of our destiny, and we are going to have to build the airplane while we're flying it. We have no choice. But on the other hand, we have the privilege of doing that together, and I hope that you all network together and help solve and create these solutions that we have to create over the coming decades. I said it earlier at the beginning of the day, I'll say it at the end. You will help save my life. So, and the life I save may be my own. So we're all in this together. We have a stake in it. And if it's not me, it's a family member, a friend, a neighbor. So we share the privilege of trying to improve healthcare on the planet. Thank you all, and let's go enjoy our gala.